good presenters today, and hopefully this will be a really good overview of what's going on in the SDDC world. And you know, they brought some swag, so hopefully you guys will be able to pick it up next time in January. So kick it off with Cisco.
Cool. Thank you very much. So I'm Kenny Kerner, the data center specialist at Cisco, partnered here with Nevin Booth, who's the smarter half of our team. He's the technical solutions architect. So we're going to kind of double team this a little bit. I'm just going to go over kind of high level what Cisco's doing in the data center, or rather multi-cloud space. It seems like data center is kind of becoming a bad word, so where everybody seems to be switching to multi-cloud. And that actually fits very well with the direction that we've gone, both our acquisitions and our R&D space. So we're going to jump in kind of at the base level of what multi-cloud means, both to Cisco and really what the industry is driving towards as a whole. You know, the Cisco world would typically build a product, put it out in the market, and just expect people to adopt it. And things have very much shifted to the point where now customer feedback is really driving our R&D and acquisition direction. What customers are actually facing in the field today when it comes to where to place workloads, should I continue to invest on-prem, should I be investing in the public cloud? We really are taking an approach of it doesn't really matter where you're going to put your workload, we have you covered. So we're going to start off. So I'm going to start off with ACI. So ACI is our software-defined networking solution. Application-centric infrastructure is what it's called. And I typically whiteboard this, but I went ahead and turned it into a PowerPoint just kind of for ease of presentation. So anytime you're looking at, right now, if you're looking at a network refresh, a data center network refresh, or you're trying to look to go to that next level, you're going to be looking at a spine and leaf architecture. And if somebody comes in and kind of tells you you don't need a spine and leaf architecture, politely walk them out the door because that is completely inaccurate. Spine and leaf architecture is the modern approach to networking today, and it will be for the future for who knows how long, but a long time. So why is that? What's so special about spine and leaf architecture? So if you think about it kind of like a chassis switch, like a Nexus 7K or 6500 or something like that, there are some components in that. Obviously the sheet metal power supplies. But then in the back you have some fabric modules. These fabric modules are what provide the bandwidth to that switch. So as you need to push multi-gigabit, multi-terabits, you just add more fabric modules to accommodate that bandwidth. And that's exactly what spine does in a spine leaf architecture. It's simply there to push back in. Simply there to provide bandwidth to the fabric. Moving on, in a chassis switch we have line cards, and line cards are what provides that capacity. It's what's actually going to allow you to connect hosts or other switches to that switch. It's your capacity layer. And that's what the leaves are. They're simply there to add capacity to your fabric. As you need more southbound ports, you just simply add leaves. And this concept right here is very unique because if you start to think about what it takes to do in a three-tier architecture, if you need to add more southbound ports or end-host ports, in most cases, you're going to end up having to upgrade or look at upgrading the distribution layer, the core layer, because as you add those additional connectivity points, you're going to be adding oversubscription to your environment. So simply adding more ports can end up in a complete network refresh, and that's a problem. It's very expensive, it's very time-consuming, causes outages, all that good stuff. In this design, you simply add more leaves. They'll just connect up to those spines, no outage, no anything. If you need more bandwidth for that southbound connectivity, you just add another spine. So between 2 and 200 spines, it really doesn't matter. You can very granularly add both capacity and bandwidth to your environment. Back to the chassis, the brains of the operation, that didn't go very well, is the supervisor. So the supervisor is what's keeping tabs on all your control plane traffic, arbitration, data plane traffic, all that good stuff. It's the brains of that switch. And that's what a controller does. A controller does the same functionality in a fabric. So the controller is able to see the entire fabric basically as one logical switch. And that's actually, right here is the most critical component of why spine and leaf architecture is so game-changing. It's now that we can actually take a fabric-level view of what's going on in the environment and treat it as just one system or one switch, we can start to do all kinds of really cool things because we know where everything is at, we know the state of everything, we know exactly what's going on across the entire fabric. So an example of that would be you have two hosts talking on this. It could be virtual machines, could be physical devices, whatever the case may be. And we know, because we have that physical level view of what's going on, we know that the first host sent 100 packets onto the wire. And we know for a fact that the destination host only received 80 packets. So with little troubleshooting, almost no effort, we know that there's 20% packet loss in the environment. We can figure it out that fast. You know, figuring something out like that in a traditional environment takes a lot of effort. I mean, it takes box by box troubleshooting, get on one, do your pings, trace routes, all that kind of stuff. Go to the next one, same thing, and repeat and repeat and repeat until you find the problem. Super time consuming, very error prone, extends those troubleshooting sessions far beyond what they should be. With that controller approach, we can actually see everything that's going on and really reduce our troubleshooting and operational burden. So some more cool things that we can do. We talked about on the security side of things, maybe segmentation. Segmentation is always and increasingly a hot topic. How do I make sure that certain workloads can't talk to other workloads, or certain users can't talk to these servers, to these devices? What we do in our spine and leaf architecture with ACI, we bucketize workloads. So we have these buckets that are called endpoint groups, and we can name those buckets. In this example, it's going to be web app and DB. Pretty traditional thing. So those buckets are nothing more than just a logical container at this point. Until we start adding devices to them. So we could add virtual machines, physical machines, whatever that is, to these different buckets, these endpoint groups. And we can define what goes in those buckets any way you want. We can do it by VLAN, we can do it by subnet, we can do it by virtual machine attribute name, pretty much anything that you want. And we place those in the appropriate bucket. And by default, ACI is a blocking fabric, a whitelist model, meaning that nothing can talk until you explicitly allow it to talk. So what we do there is we create something called a contract. So a contract is nothing more than a fancy ACL, fancy access list, that defines what layer 4 port
has joined the meeting.
What layer 4 communication can happen between these different endpoint groups. And we associate those to those buckets, and then essentially what we've done is we've created microsegmentation that simply. So very easy can we jump from basically going from a wide open Wild West environment that we have with a traditional architecture to a fully segmented environment with very little effort. Additionally, you see LD and IPS down there. We can also start to do some really cool things to get past some of the routing headaches. So in a typical world, to force something through a load balancer or a firewall, you end up having to make that device the default gateway. And that can be troublesome for troubleshooting, that can be troublesome for a lot of reasons. And it can also force you to end up having to buy very large devices, very large pieces of hardware, to only segment a certain amount of traffic. So if you make that endpoint the default gateway, all traffic has to go there. You might only really want a limited subset of traffic to have to be filtered. So what we can do is then use service chaining to say, this flow or this set of flows has to go through a load balancer before it talks to the next endpoint group. So without using routing to make this happen, we can use policy to make this happen. So we can then start to layer on policy to affect our routing and that kind of flow. Once we've done this, we've created what's called the application profile. So we create one application profile per application. That's basically what becomes how we apply network configuration policy to our environment, as we do it at application profile level. But this can be a little bit challenging if you don't know your applications very well, so which is most of our customers. So to get to this kind of nirvana, you have to understand your applications. So typically, you'll go to your application owners and say, hey, tell me what all the dependencies of this application are, tell me what talks to what, and they'll give you something that 99% of the time is going to be wrong. So what we do is we allow you, let's back up. Now that we have this application profile, and we know all the components within that application profile, we can do some cool things around operations to say, this application profile should be running at 100 all the time. The health of it should be 100. If the fabric and the controller starts to see some problems with these devices inside of this profile, we can decrement that score and say, oh, now we have this application 1 has a health score of 70, and we need to start alerting somebody. So we can do that through a push notification, we can do that just as a manual email, we can do that as any number of things, but it allows you to get proactive about troubleshooting. Back to my application documentation really is what it is. What we do is we can allow you to install these little sensors on all your hosts. And these sensors are kind of acting like NetFlow on steroids. So it's not NetFlow, but it gives you super fine-grained metadata information about what's happening on that physical, or those hosts themselves, what's talking to the web. So that all feeds into a big data lake, and we can start to bucketize and group all this information. So we're getting all this feed of information from all these servers, and we can start to do some machine learning algorithms on it to find out exactly what's going on in the environment. Again, through that machine learning algorithm, we can also say that we have 4 servers, 3 servers, and 2 servers that seem to have similar traffic flows. They're running similar processes. They're talking to different tiers of the application very similarly. We're automatically going to bucketize those and categorize those as the same. And then we can go ahead and add names to those categories. So in this instance, you can see that we've added web, this one's app, and DB, which you can see maps very cleanly to that application profile. So what that allows us to do is application dependency map our environment to start to say, you know, what does everything look like? I need to capture all that information, and I need to know exactly what's talking to what to be able to segment my environment. That's exactly what we can do here is we can see these group of servers are talking to this group of server, this particular port, and that's our application. You're not going to be able to see it here because the window down there is covering it, but you see the 443 there. So we see that web is talking to that next tier, 443. On the bottom one, we have 1536, some common SQL port, but then there's also port 22. So that's probably a problem if you think about some kind of connection between, some backdoor connection between 2 tiers. We wouldn't want that to happen. So what we can do there is we can actually push policy now down to those endpoints because we have these sensors that are running and acting essentially as distributed firewall managers. So we can actually implement policy on the Windows firewall and on the IP tables of those hosts. So very quickly, we've discovered that things are happening within this application that we don't want to happen. We can push policy to change that in real time. So we push down a change that says block port 22. There's no going to a firewall. There's no going to any point in the network to actually do that except going and saying, policy has changed, push this down, and affect that change. So it's very secure. It helps you really fine-tune exactly what's going on in your environment. Additionally, we can talk, we start to see everything that's happening in that world. So this database, for example, has a couple of other connections outside of this application. We can see the internet going to the database. That's most likely a problem. We don't want that to happen. So again, like I just said, we push down policy and say block internet. We can also see that QA and lab has connections into that database. Well, that kind of seems innocuous, maybe innocent, until you start to dig into it a little bit. So a real example of this was Cisco.com. So Cisco IT implemented this solution as our first real customer of the solution. And they had been troubleshooting an outage behind Cisco.com for weeks. Just sporadically, randomly, parts of Cisco.com would go down. Once they implemented this, they found out that this connection to the lab wasn't so innocent. And when the lab went down, the entire cluster went down. That whole SQL cluster went down. So what we found out, just in a matter of minutes, really, was that somebody had hard-coded an IP address in this database instance to a lab environment that was being fed production data. So everything was fat and happy and working until the lab does what it does and goes down. Then everything broke. So the Cisco IT went from troubleshooting this for weeks to fixing it in a matter of minutes. So it's that level of visibility and control that you get in a software-defined world that is really game-changing across the board. We also have those sensors running on the hardware itself. So you get about 80% of your visibility from the software sensors and another 20% of your visibility out of these sensors running in the hardware. So that's actually got a dedicated ASIC on those switches that's feeding this information to that big data lake. And the more information that you feed to this big data lake, the clearer and more broad your picture is of what's actually happening in your environment. So let's talk about operations and change control. Kind of a funny topic. We were just talking about that. So operations and change control in a traditional world, people have been troubleshooting traditional networks for 30 years. They've gotten pretty good at it, but it's still incredibly time intensive, And oftentimes you don't end up with root cause, you don't know why your change that you thought would work didn't work and broke stuff. So what we can do now that we actually have that controller-based view is we can pull the controller configuration, run more machine learning algorithms on them, and model out every possible outcome that that configuration is capable of. And then we can compare that against the change that you want to make. So in an offline manner, we can take that configuration that's been modeled for every outcome, say, I'm going to make this change on it, and it'll tell you predictably what's going to break or if it's going to succeed. So when you think about change control and operational aspects, you can take that result and say, hey, we've tested this, we've validated it, it's going to run, and you can close or skinny down your maintenance window from an hour to 30 minutes. You know, things like that, that are really real-world impacting when it comes to operating networks. Questions so far? Okay, moving on. So that's really, kind of the base of what we see is kind of that network area. Cisco's a networking company by, it's our bread and butter, so we do that pretty well. But now let's start talking about the multi-cloud environment in the bigger picture. So keeping in mind that a lot of the same things that we talked about down here, we can do some really cool stuff in application deployment. So the concept down here of the application profile, we can do something up here very similar in the application deployment space. So we create a couple buckets, a few buckets, and say the web tier is going to have 4 web servers, app servers, SQL servers. There's got to be a load balancer and an IPS involved. There's going to be some port communication on different ports that need to have some security rules. And then the actual bits for the application itself. Once you install these virtual machines and get them up and running, go out and pull the application bits themselves, install, and configure the application. So once we get all that together, we call that an application blueprint. So basically what that is just like the name implies, it's blueprints for what that application needs to look like. So if you think about kind of a housing example, you can build your home or design your home through an architect, and he's going to give you a set of blueprints. You can take that to any construction contractor to have your house built. Very similarly here is we can take that application blueprint and take it to any cloud and deploy it anywhere. Just like map it, model it one time, and deploy it anywhere. So that gets pushed down to the native APIs within those clouds and basically says, here you go, this is what it needs to look like. Call me when you're done. And then we just spent a whole bunch of time down here configuring a lot of policy, security, a lot of really cool stuff on-prem. Why can't we just push that to the public cloud as well? That's a lot of work and it's very secure. We want the same thing to happen up in the public cloud, and we can do that. So we can actually run ACI or SDN solution in any cloud as well. When you think about the private cloud, so these guys up here are going to do what they're going to do, how they do it to get those applications up and running. Private cloud is a little bit different. You're the one managing that environment. So how do we make that feel as cloud-like as possible? And really how we do that is through hyperconvergence. So hyperconverged infrastructure really does become your cloud target. Once you consolidate network, compute, and storage all into one simple plane, that you start to get that cloud-like feeling directly from your private infrastructure. So again, we've just modeled and blueprinted our application. We have network and security figured out over here. We have security figured out here and network, and we're just treating hyperconvergence just as our cloud workload, just like we're doing with the public cloud. One of the really big areas that we're starting to see a lot of customers go is into Kubernetes and container-based deployments. So we can do the exact same thing in a private or multi-cloud fashion that I just explained, but with containers. So everything I just explained was very VM-centric, virtual machine-centric. We can take the exact same approach to a customer or to a container environment, where we hyper-converge those Kubernetes clusters and just create that or allow that to be treated just as another cloud. And we allow you to extend that registry, that service mesh across multiple clouds. So you can end up having a container solution that spans multiple clouds. Before this came out, that was not possible. You had to run either all in one or all in the other. You weren't able to actually expand across different clouds.
And what's enabling that today? I mean, is that ACI and another product?
So the way to do that is the products behind that are Cloud Center. So this here is Cloud Center. The hyperconverged stack is HyperFlex. Then we're using Kubernetes, obviously, and then this connection here that creates the service mesh is called Istio, which is an open source Google-driven project that we have adopted and productized through support.
What happened with Cloud ICS? That's Cisco ICS, I should say.
Yeah, that is not really anymore. Yeah. Okay. So we've evolved past that into this year. Yeah. Okay. So again, up here in the public cloud, when you go to manage that environment, it's really abstracted from you. You're not necessarily trying to manage your one region versus your different region. You're managing all of your assets in the public cloud from one location. In a private cloud, that's much different. You have your storage GUI, you have this GUI, you have that GUI to manage everything. So what we've created is a way to manage your entire private cloud infrastructure from the cloud in a SaaS solution, just like you would do with the public cloud. So what that allows you to do is have a global management footprint so that you're actually able to see everything across your organization, push configuration, push change, do upgrades, all from one centralized location. Another really cool thing about putting all that management functionality into the cloud is that we're actually able now to aggregate all the world's UCS and all the world's environments that are connected to that cloud and do machine learned AI type of predictive analytics. So if you think about, Pure has a really cool cloud-based analytics solution. Nimble really kind of created that back in the day. We're doing the same thing on a much larger scale. So now we're actually able to correlate across the world what's going on and start to predictably analyze what you might be running into from a performance problem or from an outage perspective. Additionally, we can do connected service, connected TAC. So since we basically are able to see everything that's going on in your environment, why can't we then streamline the service and support aspect as well? So one of the biggest headaches, and this sounds inconsequential, but it's actually important, and I think the operators in the rooms will recognize that. The biggest headache, I think, when opening a support case is logs. Getting those logs, everything that's going to be relevant to that engineer on the other end of the phone so that they can begin analyzing. So we've automated that task. So now you can actually, by the time you get an engineer on the phone, they've already received every pertinent log and had time to analyze that before you get to call them. So you can go from, a 3-hour resolution to a problem down to 15 minutes or even less. We have case studies where that's happened, where by the time the case is open, the RMA has been sent 10 minutes later. So it really does help skinny down the time that it takes to resolve. And over here, I talked about those sensors that help us understand our applications. We can actually extend that into the cloud as well. So we can bake that into our blueprints to say everything that gets deployed, regardless of where it gets deployed, has one of these sensors in it. And we can push that to any cloud out there. So again, we're adding that visibility, ensuring you still have that same level of visibility and security controls, even if you're in the public cloud and outside your firewalls.
And what's driving those sensors in the environment?
So we can either deploy them through the platform itself, which is called tetration, or you could put them into any kind of package delivery system that you have. Okay. So again, just reiterating what I just said there. Okay, cool. So now we've built a super secure, flexible network. We've deployed applications one time, or built applications one time and deployed them anywhere. We have deployed some containers. How do we actually start to make sure that this stuff is operating, at the level that we expect it to operate, and for the price that we'd be expecting to pay? Economics becomes a much larger variable when you start to talk about multi-cloud environments. So how can we say, this is our business critical application, we've deployed it to AWS, we need to ensure that it's always running on this specific hardware. So we can actually use tools to say, take this economic variable and map it to performance. So what's really cool about that is you can do the inverse of what I just said. You can say, this is not a business critical asset. Let's make sure that it never runs on anything that's all flash or something like that. We can actually create those rules that use economics as the driver and the motivator for how that application is going to perform. We can also start to do benchmarking and automated operational escalation with this, so that we can say, instead of making an arbitrary line in the sand at 80% CPU utilization, we can allow the tool to actually analyze all that hardware of that application to say, actually, the place that this is going to start failing is at 65%. So it can automatically start to scale when you are getting notified. So that eliminates a lot of those false positives, a lot of that just arbitrary guessing of what your limits should be. Taking that concept even farther, so okay, we think that we know how well the applications are running on the hardware they're running. How do we know what the actual customer or end user is experiencing? How can we ensure that experience at the end user level is what we expect it to be? So we can actually start to look at the application from all the way down at the network stack. Oops. All the way down at the network stack down here, when we built that, all the way up through the end user itself, the browser, or whatever the case may be. And we can look at that application from soup to nuts and say, we're seeing a 20% abandonment rate at the shopping cart, just for a generalized example. Whatever that place in the application that is most business critical to you, we can say, we're having a 20% failure rate here. Why is that? And we can actually start to dig into the code itself to find out which exact SQL query is having that problem, or which exact Java call is having that problem. And then you can hand that over as an operator to the development team or to the software engineers and say, look, this SQL query needs to be rewritten. It's breaking things down. And again, using economics as our driver here, we can start to bring IT value to the business itself by saying, we need to upgrade or we need to do X because we're losing $2 million by not doing it. So we're actually able to take, from a technology level, map that to the economic business impact level, what's happening. And that's actually pretty revolutionary in the IT industry. We try to do that, but it's never concrete. It's always just kind of up to somebody's opinion of how important this is. We're actually at a full stack able to take a look at exactly what's going on in that environment and map it to business criteria. And then lastly, this is all super cool stuff. How do we actually expose this to the end users? How do we give them the ability to do self-service? So front-ending, all of this through APIs with a workflow engine, whether it's ServiceNow or something else, so that users can actually interact with this technology very seamlessly. You can put the guardrails around them to protect them from themselves, but still give them the freedom and autonomy they want. The last thing they want to do is call IT. I think we're all pretty aware of that. And then lastly here is just kind of putting it all together. So this is really the product page of everything that I just talked about. So obviously the network is built on Nexus and ACI, QCS and HyperFlex for our compute and storage platforms. Policy driven, that policy that I first talked about. Cloud Center, which is that blueprint once, deploy anywhere. ACI, again, at the policy level. App Dynamics, which was that end user, business critical type of conversation. And then the reference architecture for everything we spoke about. So these are kind of the general pillars of what creates a cloud strategy. And these are the areas that Cisco plays in over here. And that's really all I have. Thank you for your time. And Nevin's going to take over.
Oh, it's amazing.
I don't know how he does that. So I don't know how long this takes. He ends exactly on time.
Thanks, Kenny.
Thank you. Be right back.
All right. So, as Kenny mentioned, for those on the recording, my name is Nevin Booth. I'm the technical solution architect covering commercial from Pacific Northwest, which includes up here in Alaska. So, kind of switching gears a little bit, I'm going to dive into some of the integrations we've done with ACI and VMware. Kind of demo recordings. I don't trust Wi-Fi, so I try not to do too many things live. This was taken about a week ago by one of my colleagues down in San Jose, and I ripped him off. So, we go to that. So, how VMM integration works. So, basically, VMM domain, virtual machine manager with VMware. How do we use ACI to then control that policy and bring it all the way down into the hypervisor itself, or into the virtualized environment. So here we're going to have an admin connect, an endpoint group, which as Kenny mentioned is basically a VLAN, to our APIC. APIC's going to make a regular northbound API call to vCenter to that virtual switch. There we go. Right. vCenter is going to make the change and create the new port group. So we're not changing how VMware does what they do and how they do it well. We're just integrating that northbound API layer, and that will provide this functionality in here. And so it's kind of hidden behind the screen here. Right, the new port group gets created within inside of VMware. What we've done, so this works regardless of the hardware you're running on from a virtualized host perspective. So if you're running UCS, there's an integration within the API to actually modify the UCS manager to actually, trunk that VLAN down. If you did have a fabric interconnect in there, you're using a standalone C series, or you're using someone else's compute environment where that's not needed, there's all that extra layer of networking. Right, from one place, whether it's the network admin going into the API or it's the virtualization engineer going into the API or through the vCenter plugin, they're creating this once in the network and getting it pushed down to the host that they need it on. So I will see if this video will play here. Walk through it here. So here you can see, my pointer here, we're just kind of showing that, whether we're looking at the different web servers here, you're seeing the network adapters, you have the visibility you need inside of vCenter, right? Right, manufacturers VMware. This isn't like our old Nexus 1000 and that we had in there that kind of tied in and replaced the virtual distributed switch. This is the VMware one that we're just writing on top of. So if we go in, we can actually bring up the ACI fabric. So there's a vSphere plugin you can install.
Is this compatible with the HTML5 client yet?
That's a good question. We're running this one. I don't believe it is. I think they've tested it and some of it's working in HTML5, but not all of it. So here you can see we have our contracts, app2db. Here are these endpoint groups, and here's what servers are living within inside of those different endpoint groups. Right, so not having to leave VMware, and I just restarted the video, so we'll give this a second here. I don't recommend embedding things in PowerPoint. It makes it pretty, but then you're just going to have to wait for it to run through it again. Up here. Right, so here we're showing we have different tenants, right, which are just mapping down to the VLAN ID that's been created. Back up. So then, we're getting better at it, but, move things around a little bit, lines kind of overlap as we draw them. But basically, this is the same view the network engineer or that network engineer persona is going to have within inside of the API controller. We're bringing this here into the ACI fabric. And here's the exact same drawing, looks slightly different, right, because we have our own little fonts we use, but, you can tell it's very similar to what you just saw within vCenter. So, where we're going, because everything is API driven, the goal is as much as we can integrate, we will have the same dashboard, the same functionality in multiple places. So you're not jumping around back and forth to figure out, sorry, I'm distracted on it. In order to get that information, if you're inside of a tool such as VMware, you shouldn't have to leave VMware to, get that information about your network. We go into some more of the integrations here. Back to our VMware client. You can see here we're going ahead and we're creating a new endpoint group. And that's directly from the vCenter plugin. We're going to go ahead and name this demo. We're going to select our high-level tenant, our verb, and then our bridge domain. And once you learn the lingo of ACI, it's no different than we had to learn all the lingo that Cisco forced everyone to learn for 30 years. Now we're just forcing everyone to learn new terms. So as you can see, we go ahead and create the There's no contract, which is why you don't see a line between that new endpoint group, right? So we created a new VLAN, we just haven't given it any active or contracts. You can see here within the regular networking tab, right, the VLAN ID, and we'll go in, we'll click off, we'll click back here to refresh. And you'll see it here within the network view router view as well, within inside the APIC. So, like anything, right, you have humans are going around and making these changes, right? So people are going in and creating things within VStat, whether it's the virtualization admin or the network admin. Well, how do I know if there's an error or an issue, fault? So what we're going to do here is we're going to go ahead and create a new physical domain mapping, and that's where it ties some ports together. But what we're going to do here is we're going to go ahead and actually create a duplicate VLAN in the environment, right? Somebody didn't check the spreadsheet. Hopefully people aren't using those, but right, it's right. Somebody goes in and creates that within the environment. We'll go over what there are faults or are newly created, and here you can see it's really hard to read, but it actually gives you it actually gives you very easy to read information that this VLAN has already been created somewhere else in the environment. You can see we now have a little warning sign on that endpoint group we created in the last example. And here you can see debug message, in cap already in use. And you can see the interface we attached it on within the environment. So this is visual right within vCenter. Again, you're not having to hop out to the CI APIC to see that fault. So troubleshooting, as Kenny mentioned, how do we get it? So troubleshooting is quicker and easier for everyone. No one likes to spend their time troubleshooting an issue. You have your boss yelling at you, you have an app owner yelling at you, you're trying to figure out what happened. So this is right within the vSphere web client within our plugin. What we're going to do here is we're going to create a new troubleshooting session. And right, somebody told us these two endpoints are having an issue talking to each other. So go ahead and we know they're a virtual machine. And this one, we're already in the data, even though we just have the IP address, we know it's in our endpoint group web right here. And we're going to go ahead and select our endpoint on the other side. Now what we're going to do is we're going to start a troubleshooting session. So here, because we have that system level view, we're going to inject traffic into the fabric between those two endpoints and capture them within the environment. So you can see where we started our injection. It went to the app server. Here's the MAC address and IP address. The endpoint group we have up in the CI fabric and then back down. Here we can see the contract we have. It's just any. We don't recommend that, but right, they do end up in an environment. So here you can also go in and run a trace route between different events as well. Go back to our fault section here within our troubleshooting. You see we have one little fault. And what we're seeing here is that we had CRC errors. We're going to throw that down a little bit quick. We had CRC errors happening between those links on our network. Right now, as a network engineer, I know to go troubleshoot that in the environment and not where I need to look about why that's failing. Right? It wasn't based upon I had the incorrect ACL, so I have a health issue within my network itself. When you create that, so let's say you do have a larger team that's distributed, right? The virtualization engineer can go in and say, you know what, I want to see, somebody told me this doesn't connect. They run this troubleshooting session, they give it a name. Like, look, there is an issue, right? We're not making it up. Trust us, network team, we are seeing packet loss, we're seeing CRC errors, and we're seeing, contracts denying this, but to the separation of duties, we might give them the rights to change that in the environment. Due security has to bless any of those changes. When the network engineer, who isn't as familiar with vCenter, decides to log into the APIC, this troubleshooting session, we call SEVT, actually appears. So he doesn't have to go in and type in the endpoint names again and run the test. All of that test is in the APIC. What he's used to using now has the data he needs, and you can collaborate. So if he goes in modifies the troubleshooting session, it's going to refresh within the vCenter plugin as well. So that's some of the integrations. As Kenny mentioned, right, for multi-cloud, it's really the distributed data centers we have. So I'm going to kind of switch gears into the rest of the portfolio here, kind of following along the lines that he did. So, right, we start doing cloud native or on-premises, environments. This is really why we're getting rid of the user group. Is public cloud is great. Everyone's using it to some extent. It might just be a SaaS offering, right? Your company may not, believe in data privacy reasons, maybe connectivity reasons. There's excuses where the cloud doesn't make sense for everyone. However, the experience that cloud provides, and that does make sense for everyone. Being able to understand what does this cost me to run? How do I consume something out of service? Maybe I have my email up in the cloud because, right, I don't want to run Exchange anymore, but maybe that's all I put up there. Or maybe we do some file sharing with, other companies. So maybe I use something like a OneDrive, from Microsoft, or use ShareFile, or one of those other technologies. Everything kind of exists out there. But when you want to start building things, on premises, then we have to figure out how do we do that. So as Kenny mentioned, right, HyperFlex really is our multi-cloud platform, right? At AWS, at Google, they're not spending a lot of time anymore managing hardware, right? The beauty is when you go to use those services, you don't care about the hardware at all ever again. Unfortunately, when us in IT operations, we still have to care about hardware when we create a private cloud. So how do we make that as low touch as possible, very easy to expand and consume, so that we can focus on things that add value to the business, right? Helping enable those things we want to provide as a service, not spend all of our time building things up from scratch, figuring out multi-tier architectures of this is how I manage storage, this is how I manage network, this is how I manage compute. How do we create a platform that we can use for any of those? So within the stack here, and that, as Kenny mentioned, our application blueprinting, we have Cisco Cloud Center. App Dynamics is an acquisition we had. They allow us to get into the code level of an application, really understand what's happening within that application stack. We have our Workload Optimization Manager, which is a partnership with Turbonomics, that we've done a lot of integrations with an OEM their product. And so that's really how do we dynamically scale environments, right? How do we give that elasticity? How do we know we're running things the way we need to? Do we have the right amount of resources assigned to the system? And, or how is it being managed, right? Are we having to constantly check it? Do we wait for a user report issue? Or do we have a system that's built on machine learning that is doing that operational component for us? Our Cisco Container Platform is based on Kubernetes, and we're really bringing that to more parts. Right now, it does run on HyperFlex. And one of the components is when we started down the container journey, I could do a whole 90 minutes just on containers, right? Everything was about stateless, right? Every container is going to be stateless. We're going to have our data services tier, and that's it. As people started to evolve microservice architectures, there is a need to have state within certain types of containers. So when you get to that and you want to have a more flexible architecture, not have the rigid, SDLC rules, well, with Kubernetes, we have a flex volume driver that we can actually present persistent storage up into a container. So even though we still get to treat it like cattle, we still get to kill it, spin up new ones, and go very quickly, we can still at least have persistent storage for that. We're not necessarily pushing everything off to a NoSQL solution and then bringing state in that, but we can actually maintain state, with containers and through that upgrade cycle you get with Kubernetes. And then here for that IT operations aspect here, we have our Cisco Intersect, which is our management as a service platform. But how do we make the IT operations management of the infrastructure so that you don't have to do with Amazon or Google easier and more seamless? So we talk about hyperconverged, right? We have traditional infrastructure tiers, right? This isn't gone, right? If you're not building a cloud-like environment on premises, and that you have legacy applications, or you have a mainframe still, there's plenty of them out there, right? This architecture can work very well, but what we've seen is that we move more into that converged infrastructure, right? Your flex blocks, vBlocks, flash stacks, to where you are starting to bring the management of those systems together, but they're still model but the application is not built in a way that allows it to natively stretch and protect a 100% virtualized environment. So what we've done here is taken the storage, which is our HX data platform, and we've taken the compute side and networking side from the Cisco UCS component and brought them in together in the Cisco HyperFlex. So when we talk about the storage component, one thing that differentiates HyperFlex from other things in the market is that we built a log structured object-based file system from the ground up to support these workloads. So instead of leveraging like ext4 or leveraging RAID, what we've done is just created a Hadoop-like system where you now, instead of having RAID that manages how your protection is of data against disk, what Hadoop did is just create multiple copies of that in the backend. Similar to how Amazon does S3 storage, this is that commercialization of a cloud-like product, cloud product, into something that's consumable by, enterprise and commercial spaces. So we're having this scaled out distributed storage. We're not bound to the limits of RAID. We're not bound to how that behaves. We're able to actually, from the ground up, figure out how we want to deploy those bits of data across all of the drives that we treat as one logical environment. I mentioned because it is an object-based file system that we're done just front-ending with protocols, right? That's how we're able to get container supported and the next generation app support. Is we're not starting with block, layering on protocols like file. We're starting with file and just putting access proxies in front of them. That's a much more efficient method because in the end of the day, what you are wanting to store is those files and objects within it. So you're not having these multiple layers where you're basically recasting what type of data flow you're having just to get data on the disk. So if we look inside of a HyperFlex node, this is essentially a rack mount server. Right, we're going to have some amount of disks and some amount of caching environment, and we're going to create a data store and volume, very similar to anything else with virtualized workload. So within the hypervisor, we actually insert this VIO visor. Essentially, this is a VIB. It solves as a VIB, so VMware installation bundle. It's a storage driver. This is intelligent to know about any traffic coming from one of these virtual machines that is going to one of these data stores. It's going to intercept that and proxy it through NFS to these controller VMs that live on each one of the nodes. And so it is aware of all of the drives across everything in the system. There's a metadata map for this data. And so we're able to, instead of, saying this IO visor writes to this controller VM, if I move forward here to a to an actual clustered environment, my IO visor that sits here within my hypervisor can talk to all of these controller VMs at the same time. So instead of having write local and then replicate, we're actually able to consume the cache across the entire environment. What else we're able to do is we can sustain a failure of the controller VM on one of these nodes, and the node still houses VMs. Because we don't actually care about having that locality, we're able to leverage the cache off of any other node and still write the data down, even if that IO visor happens to be down. Right? If you want to scale the environment up, so you can just add more servers into the environment. As you do that, data is going to dynamically rebalance itself across the environment. I have one more animation there. And so what's important here too is you can also individually expand a given node. So let's say you have extra drive capacity, disk capacity in it. We start as few as 6 disks. Maybe we have 23 disks available in our small form factor 240. Well, you can just expand disks equally across those nodes, and now it just becomes part of the larger pool. So you can start to independently scale the resources you need in your environment. I created an animation for that. So you can so here, we want to scale capacity within our nodes. Right here, we're going to not change our usable compute resources, because all we're doing is adding disks, yet we're going to add usable storage. Likewise, we add converge nodes, we're going to see a scale of both of those happen to our environment. And then finally, we're able to do compute-only nodes in the environment. Because we have that IO visor in here, and we don't require the controller VM to be local to that machine, this architecture enables us to do compute-only nodes into the environment. So if, let's say, you have a use case for, VDI inside of a mixed VMware cluster, and I had GPU requirements for a couple of users. Well, instead of putting GPUs in every single node, which gets very expensive, especially if they're NVIDIA, because you have the licensing attached to them, well, now I can use VMware technology that I know and love, like DRS affinity rules, and say these VMs have GPUs, or these VDI VMs that are deployed have my GPU assigned, and I'm going to pin them in an affinity pool against these compute-only nodes. This is one example. You don't have to make it rigid. It could be my general workload environment, and whether my VM is running here or here, I'm going to get the same storage performance regardless of its locality.
Can we step back on the slide before this?
Yeah.
So on this here, so you have the IO visor, the Viv in there, and you've got VAAI. What is the controller actually doing for you? Is it on every node?
So yeah, the controller sits on every node, and so the controller is what's processing the data rights down to the disk themselves. So the IO visor is directing it out to different controllers. And then the controller is doing data services layer like dedupe, compression, and then there's a good point. So with dedupe compression, it is always on within HyperFlex, and it's in line, whether it's a hybrid array or an all-flash array. We actually have coming out here, might ship in December, probably going to be January at this point. We are going to have an option to put a Hercules card inside of our nodes and actually do hardware-based compression offloads. We'll free up some vCPUs that these controllers are using. At the same time, we're changing the compression algorithm we're using because we can offload it to hardware and that too, so that's gives a much better result. We're using SNP today, and we're going to be moving to gzip on the back end. So great. And then if that hardware accelerator was to die in one of the nodes, it will fill back the software. So there is that little more tax against that controller VM, but it's still able to use that new compression algorithm and keep that consistent across the environment.
How much resources do the controller VMs take up?
Oh, yeah, good me. So they are, memory-wise, it varies by form factor by a few gigs. It's about 72 gigs of memory and 4 vCPU. And that on the all-flash model, we actually do plug, I think it's 8 vCPU into them. So part of the reason of looking at, how do we, at Cisco, because we are, we have roots as a hardware company, how do we combine the best of both worlds? How do I take good software, leverage the right hardware offload, to provide that? So that's why we're looking at and investing in those offload cards so we can free up more of those resources.
Okay, and then you said you don't have to worry about data locality. So when a write happens, does it happen across all the nodes, or where is it?
Yeah, so when a write happens, that it's going to go from the IO visor. It's going to then write to multiple controller VMs. So 3 of them at the same time, and that if, let's say, you had only a 3-node cluster and only 2 were available, it would just write to those 2, and those 2 would manage where we would. So we white stripe the data across all of the disks, and then, unlike RAID, we use replication factor and RF factor. Forget the vSAN term for it. Essentially, it means the same thing for all of us, right? How many copies of the data am I writing? So because I'm striping and chunking that data up, I'll have a little bit of the data here, here, here for copy A. Maybe copy 2 sits here, here, and over here. So we make sure that we have that, we don't stuck with that locality from a failure perspective. And then when we get into larger clusters, we have a local availability zone mechanism that makes sure that we're not having those multiple copies across too few nodes as we start white striping that out. But it's when you get over like 8 nodes in a cluster.
What's your minimum cluster nodes?
So the minimum cluster node today is 3. We have HyperFlex Edge in that, which doesn't have the fabric interconnects. It's currently at 3 nodes. Here launching shortly will be our 2-node configuration as well as a 4-node configuration. And I think I actually have a slide I can get to on this here.
Cool, thank you.
Yeah, absolutely. So we have some data protection we start building in with HyperFlex 3.0. We're on the 3.5 now. So with everything, we're kind of working on how do we make it so our customers can have, some light DR test plans and some functionality in it, built into the system for migration. So what we're able to do, again, this is different from the idea of like a stretch cluster. Actually, you're using, layer 3 and actually doing long distance replication, is you can go through and actually build out test recovery plans for doing DR, right? So you can test moving that VM across your data centers. You can reprotect, right, do the replication back to that environment, and then also do unplanned failover, right? So it's a pretty powerful data protection story we have here. And then in the release coming out, we're actually adding support for VMware SRM and that. So you'll actually, HyperFlex will show as an SRA downloadable from VMware. So if you have workloads you're already using SRM runbooks and you want to continue using those because you have the model down, operationalized it, we'll be able to support that here in the near future. And we'll also be able to support it split. So let's say you have, some workloads in SRM, but you have other systems maybe on clusters that don't have the licensing for it, right? Maybe you just want to protect some of your more critical QA systems that, you haven't had that, in your main production cluster. You can use the native replication built in. So right now, it is a point-to-point, one-to-one replication. And we can replicate even this across different clusters. So you could have all flash in your primary data center or hybrid in your disaster recovery site. It doesn't matter because we're just replicating the data over. It's snapshot-based. We get down as low as a 5-minute, RPO. Really, we leverage partners when you start getting into, essentially near zero, and that. So you can start using different tools out there that, are actually going to intercept that traffic and send it over. So, if you're really needing, that kind of more enterprise class feature above and beyond, right? I have a 2-minute recovery time. Unfortunately, this isn't going to work, but 5 minutes is pretty good for a lot of systems. And so it's something our customers are starting to use. I don't know what to do. All right. Like anything in IT, you reboot it and it magically works. So, with HyperFlex Edge, when there are 2-node cluster coming out, so the problem when you start clustering things is, well, if I have only 2 of them, how do I know I don't have a split brain situation? How do I know both of them don't think they're active because I just lost the link between them? So using that management as a service platform Intersight, we can actually create an invisible arbitration service that runs using Cisco Intersight as that arbitration. It's not a true witness, and we were able to change it from a type of environment where you just have 1 witness per cluster. Some technologies have 1 witness can run the multiple clusters. We're actually doing an arbitration service in the cloud, so that way we can go in with our edge clusters, can deploy 2 nodes, have access to the cloud, and that from a witnessing perspective, so that if there is a failure locally within the network, it can serve as that tiebreak, as that arbitrator, so you can actually stay up running in a 1-node environment until you brought that back up. Again, this is really that robo use case, nothing meant for the data center, but right, I have a retail location, or maybe I have a remote office that has local file print, maybe another service that I want to have the availability that I get with hyperconverge, to be able to bring that into a different environment. So with using Intersight, one of the capabilities we have within Cisco Intersight is actually to manage HyperFlex. And we actually do multiple cluster install all from within the cloud. So you actually can build your policy for how you want to provision, right? All the IP addresses you need, your subnets, your configuration, and push that from Intersight out to multiple locations at the same time, right? So as long as you can get that environment up and running from a management IP, right? So it requires, either DHCP in the arm or a really low-touch technician to be able to put in, here is the IP address. I can remotely manage it. You can claim it into Intersight and then deploy the cluster completely, being hands-off remote. Right, for Alaska, it saves time for people to travel out to really far remote locations. The person on site who might be there can plug it in and at least configure an IP on it for you. You can then take over remotely for it. So right now, as I mentioned, we have our 3-node cluster for the edge environment. When we bring out the 2-node, we are going to work with being able to expand that up. Right, so you could start to add a third and go up to 4 nodes. The reason this expand has an asterisk, the screen's kind of hiding it here, is the expansion will happen on a 10 gig option. Right, so if you have this 1 or 10 gig capable at the edge, but in order to expand from 3 to 4 nodes, we really need 10 gig in the environment to be able to do that. So our container platform. And I won't touch too much on this. I'm happy to, dive in with anyone on it later. Right, so there's so much to Kubernetes. What essentially we created, in addition to having, support for Kubernetes through Cisco TAC and the container storage we have networking within the environment. So all that stuff Kenny talked about with ACI, we can use the Conti ACI plugin for Kubernetes and actually bring ACI policy down to the container level itself. And then the other big advantage we have is if you go and use, let's say, Amazon EKS, which is Kubernetes within AWS, they're providing that management of that Kubernetes environment for your developers, for your DevOps team. On-prem, what we were looking to do is how to use an IT infrastructure organization provide Kubernetes as a service out to the other teams. You're in an environment that has multiple dev teams or DevOps teams. You may not want to try to create one giant Kubernetes cluster and do a bunch of RBAC controls and this fine-grained utility, fine-grained access to try to limit who has access to what resources and segment that out. What we do is running on VMware, we spin up using Kubernetes, which we've containerized on VMs, and spin up multiple new Kubernetes environments on premises within VMware. So that way each dev team or maybe each application project you're doing, you can hand off their own unique Kubernetes environment, which means the velocity they have with their sprints doesn't necessarily have to match up with someone else from a CI/CD pipeline perspective. Right? If they need to be on one version versus another team on a different one, maybe you have applications running Conti and ACI mode. But you have a dev environment where you're just running native Conti from a networking perspective. You can do that by spinning up multiple new Kubernetes clusters dynamically through the management portal. So, again, we're at the VMUG. So when we start talking about how do we integrate management and monitoring and make things easier for administrators, so we have our HyperFlex Connect, which is an HTML5 interface. It runs on that controller VM. So it's another thing the controller VM provides. It clusters, and one of them with a floating IP will respond and answer with the HX Connect is kind of our management dashboard, right? You can see storage IOPS for the environment. You can schedule replication. You can schedule your snapshots. You can perform upgrades to it. Likewise, where all of the events that happen within HX Connect, we push up into our plugin we have for vCenter. So within vCenter, you can go in and use, after you install it, you don't have to go out to HX Connect in order to do work. There are a few items, such as future upgrades, will be done through HX Connect. And part of that's just because of the trying to time releases of our upgrade cycle with upgrade versions of VMware gets a little difficult. So things that are easier to kind of decouple, we are, but for the most part, we're leaving as much functionality as we can within VMware as possible. And so whether you're going to create a snapshot, and I don't have a slide on it here in this deck, but one thing that's unique about our snapshots is because we have an object-based file system underneath, everything is pointer-based within the environment. And so instead of creating a redo log-based snapshot like the VMware has, you have your Delta files and those grow over time. When you do it with HyperFlex, we integrate with VMware, we intercept that request to create a snapshot, we put a Sentinel in, and so VMware sees a 4K redo log get created. But what we've done is on the back end on the file system is created that pointer. And so when you do go to consolidate snapshots down the road, it's as quick as that pointer consolidation, which is a matter of seconds, versus potentially hours long of a Delta file. And so this helps our backup vendors when they go to do their snapshots as well, is that if you put that Sentinel in that doesn't have any overhead, it's just running on the file system itself, and that when something like Rubrik comes in and goes to do a snapshot-based backup, and that it will hit the VMware API, we already have that Sentinel in. Any snapshot taken by VMware after that Sentinel's in just acts as a pointer on the file system. So now, if you had a lot of changes going on during that backup window, and you went to then consolidate, and you have that kind of stun, not that kind of hit performance right when your backup finishes and you're consolidating on the snapshot, you don't have that necessarily impact anymore by putting it on the file system. It's similar to what a traditional array would do, we're doing that with inside the file system.
So HyperFlex Connect, does that live on the controller VMs, or is that a separate?
It lives on controller VMs.
Okay. So
If one controller VM goes down for some reason, the HyperFlex Connect will still be running.
Yeah, it runs on all of them. It does a GUI redirect to one that's coming in as a master, but it manages that clustering and moving it forward. One of the innovations we've added from a VMware integration standpoint is when you're in HyperFlex Connect and you're going to do a firmware upgrade or an update to the Anchorage data platform, we now can update VMware directly through this UI app at the same time. So it's as simple as selecting, after you upload the firmware to the Fabric Interconnects, selecting which version you want to go to, you would drag and drop the file into the HX data platform, you drop your VMware ISO here, and we're actually able to go through and upgrade all of those things with a single reboot. So because we know, and we, as a system, what firmware you're doing, what those firmware's dependencies are, whether they require a restart or not, our data platform, not all updates actually require us to reboot the node, and then for VMware, obviously, we need to restart the node itself. We're able to time those from a sequencing perspective, that as it goes to the maintenance mode, we can stage everything on the hardware or in the software, so when you have the one restart, you're back up and running. So instead of being a sequential, maybe an automated workflow that has multiple restarts, you're able to reduce that down. So a little bit more about Intersight. So as Kenny mentioned, we are bringing in telemetry and analytics into the platform from all of our customers who have it installed. Right? So we see this batch of memory, maybe we have a larger RMA on from a vendor that has an issue, we'll know which customers have that potential impact. As we see potential performance issues, whatever happens in the environment, where we have a lot more telemetry data we can use to start building that out. We have policy-based orchestration. So if you're familiar with UCS or the HyperFlex environment, you have UCS Manager, which is building those service profiles. But what if you had a standalone just rack mount server sitting on a remote site? With Cisco Intersight, you can start bringing those UCS Manager-like functions of, here's my profile, here's my BIOS policy, my VNIX I want to run, NTP settings, DNS settings, the things you would normally configure on that out-of-band management. You can build the policy within Intersight and send that down to the individual node. And everything within inside Intersight is API-driven. So we have a front-end API. There's a Python SDK out there as well as PowerShell. Command like pack coming here soon, but the Python SDK is there as well as a general REST API. So if you companies that don't love our GUI, you can go ahead and create your own or do everything through scripting. So what's coming here in Intersight now, this is in beta right now, this is bringing an orchestration component into Intersight. And again, because it is that SaaS offered solution, as it becomes available, it goes through the QA testing, it gets published out into that dashboard. So under like a traditional management tool that we provide you on premises, right, we release a new feature set, you have to go download it and go through the upgrade process where that management tool is. So in this workflow here, that we're actually able to do tasks to say we need to add a VDC. Going to update some storage policy, and you can build these workflows out. So let's say I want to talk to my northbound Nexus switch and configure a VLAN, or maybe it's my APIC controller, right? If you're in ACI mode, I want to talk to ACI, create a new endpoint group, and bring that all the way down to the vSwitch, right? ACI is going to do that for you. with the integration with VMM. But let's say you're not on ACI yet, you know, you're not at that network refresh point, and you have Nexus gear in the environment, you can go ahead and create a task that's going to create the VLAN on your Nexus, go and modify UCS Manager, and then also modify the vSwitch for you, all of this in this environment. This is kind of one example. And then here, I changed over here, there's a code view. So whether it's a JSON or a YAML environment, if you're not into doing drag and drop and you don't like using a UI, which I don't, and you're like, I want to type my way to success, right, you can actually go ahead into a code view and start describing the environment. You can then take that JSON file, replicate it out, maybe you move that into, you know, your Git repository, and now you have version control on it. Use the API to drop that back into Intersight. So this is our, you know, the CI/CD model. So this is the features we've added to Cisco Intersight this year. I won't go through all of the components of it because that's just an eyesore, but some of the kind of highlights here is, right, so we started adding, you know, standalone C-series management, where again, we're creating those policies for non-fabric interconnected servers sit out in the environment. We have an HCL tool within there now, so as long as you have the drivers for VMware installed, or you're using our VMware custom image, you're going to be able to see, if I want to do this version of VMware, am I at the right firmware level, an HCL level compatibility check across the environment. If it's, you know, about 3 weeks from now, I'll be able to add another one in here that shows we have that same sensor and driver you can add into Windows or Red Hat. And I have a bare metal host I'm going to upgrade to have the right firmware version within it as well. So there's one other component here is you have those C-series servers that are sitting out at remote locations. Well, great. We've provided you a way now to manage them from a central location. You can provide policy to them. But like anything, you still need a firmware update. Before that required you connecting out to the IMC or the SIMC on each individual node, the lights out management, and going in, restarting the node, going into our hardware update for HUU, and applying it. Through Intersight, we can actually push the firmware upgrade from the cloud down to that remote site. Right now, it is a push and it happens environment. They're adding the scheduled functionality feature into it here soon, so that way you can say, you know, it's the middle of the day, I'm going to do my work and say, okay, this site's going to go at 10 p.m., that one at 11, this one at midnight, and you go to bed. First, I wake up at 10, click go, I wake up at 11, click go, right? So things we can do to help make people's life, you know, easier from an IT operations perspective. Obviously, maybe you want to set an alarm at, you know, 1:30 to wake up and check your phone, make sure you get like an alert, make sure the system came back online, or if you have a paging system in your environment today, you would just leverage that, you know, if it didn't come back on within your maintenance window. So lastly here, I'm going to talk about our workload optimization manager. So I have HyperFlex. I now have a target to land my applications on, my virtual machines or my containers, right? But every time you ask a developer, well, how many resources do you need? They're like, I need 16 vCPUs and 120 gig of memory, or 64. Sometimes they're weird, and they're like, 59 gigs of memory is exactly what I need. And like, I don't believe you, because you're a developer. So what if you could then use technology to drive those decisions making, right? Take the human element out of it and look at, you know, what it is. So as we're in I click go too quick, right? In a multi-platform world, right? It doesn't matter what your weapon of choice is, right? We're in the same problem, right? Not everything is going to be a homogeneous environment, right? There's going to be different products, different use cases of how we go in, and it's not always going to be on premises, right? So this will work whether you're using VMware, whether you're using Hyper-V, AWS, Google, OpenStack, list goes on for being able to manage and how I effectively manage this workload. So in IT, we always care about the workload. So we try to care about performance as much as we can, but we're limited by our budgets. We have to care about compliance, right? So it's just the days of IT going, hey, I did what you said, I deployed it, is kind of over, right? People expect IT to have the controls in place. So when they say, we can't do X, we can't allow this to happen, or this application needs to live on premises because of data sovereignty laws, right? GDPR is a great example of that. Within the EU, as I start getting this multi-cloud world, how do I make sure that no one deploys this application, but is it dynamically moved over to a system and out of country or out of that sovereignty, right? So compliance really matters. And then, of course, we all care about cost, which we didn't have to, but it's just kind of the nature of IT, right? We don't get more money. We are asked to do more all the time. And that's, so how do we do that within the workloads themselves? So we started looking at workloads that manage themselves. There's a few different, components of that. So you have, where do I place my, workload that's most cost effective? I'm going to mainly focus, even on process. So with Workload Optimization Manager, everything has the concept in it of a supply chain, right? Now, there is a cost to running it. Even though you already bought that hardware and it's in there, there's a cost to your business by over allocating resources to an environment, right? If you get into a larger organization and you guys have and it's not a very steady state environment and things start to flex up and down in your own data center, well, maybe you're paying for power and you can turn some nodes off, right? Maybe I don't need all this compute right now, but I had budget to buy it, but I don't want to waste the power from it running all the time. So now I can integrate UCS directly into CWOG, and it can manage the physical aspect. Do I turn that chassis back on? Do I turn those blades back on? Or I leave them in an offline state right now because I don't need them drawing power. I don't need the resources. And then, where are things living in my environment? So VMware DRS is a very reactive environment, right? So DRS works well. You set your thresholds and your policies within it, but it waits for something to happen to cross a threshold off of a set of metrics for it to take action. Running VMware a long time myself, right? You have a cluster, you go through, you do all your maintenance, all reboots. Even clusters that are a couple nodes that are sitting there not doing anything, right? Because you didn't hit any trigger that would then force it to move over. With Workload Optimization Manager, because it's running machine learning on the background and building that data lake of information about your environment, it knows to move things out ahead of time. So it doesn't wait for that trigger to happen. Once it's been in your environment for a while, it knows every Tuesday, these 5 systems get really busy. Let's look at which hosts have the least amount of activity at that time and make sure they're placed there within the environment. So it really brings a lot of that kind of tribal knowledge that an operator might have of how I balance out my clusters and how I manage it, and deciding that if you leave or go on vacation and the node went down, right, the next person's not figuring out, well, how did he balance this out right? How did he take my governance rule that said these systems live on these hosts for a licensing reason, right? So Oracle's another great example, right? If you can prove to Oracle that your virtual machine is not leaving these given hosts, even if they're in the same cluster, right, you don't have to license everything in the cluster itself. You have to prove that to Oracle. Well, how do you do that? You can use, some DRS rules and then you get to go pull those reports, or you can use something like Workload Optimization Manager, which again is going to tie into VMware, and no, those aren't getting moved from a compliance and government to a host that has a ton of cores on them, and now I'm paying for those and I'm doing an Oracle audit. So a lot of the use cases we have for on-premises, so with CWOM, which I don't know if I mentioned earlier, is under the cover with OEM Turbonomics. And we've done, Cisco IT used Turbonomics, had great result within one of our data center builds. Is we started bringing and adding a lot of integrations into the other things we have on our platform. And for UCS, we can take power data. We can take information about that physical hardware and bring that telemetry into CWOM to make decisions about where things are placed. As Tim mentioned with tetration, our way of deploying sensors into the environment. Well, because with tetration, I know every packet and every flow that's happening in my environment. What if I want to take these systems that talk a lot and reduce their east to west traffic dependency across my network and bring them closer together on the same host so they have the exact same, they're going local within that hypervisor across that vSwitch and back to one another. I can do that because I can take the telemetry from tetration and feed that to CWOM. Now in CWAM, I could go in and say though, because I have these anti-affinity rules, right, I don't want all 3 copies of my app server to live on one host, because if that happened to die, right, while HA would be started, I'm going to be down for that time. Well, maybe it looks and it will trust or it will honor your anti-affinity rules, but still optimize things as close as it can within that environment to get you that performance. And so there's there's a lot of other integration we have to take that telemetry data to help make that system more and more intelligent about how it places workload within your environment. One of the use cases we use at Cisco IT is on workload resizing. So whenever you start to tell application owners and everyone else that you're going to resize their workload, right, you're going to maybe take some resources back. You guys are over-provisioned. Here's my data that shows you don't need it, right? The moment you take that resource away, even if they did a code push that had like a bad SQL query, they're going to blame you for getting rid of their resources that they said they needed, right? As an IT infrastructure person, you're always at fault, even when it's not your fault, even if they need to back it up. So when you start from a culture perspective, go, I'm going to resize your workloads, you can not just bring them down. The real value is when you approach your customers and say, I'm going to size you up when it needs it. So what we did at Cisco IT is after 10 minutes of it throwing, crossing a threshold, we'll automatically start adding, hot app memory and CPU up to a threshold on those different application servers, right? So there's value to that application owner knowing that he has some elasticity without building necessarily into his pipeline. Maybe his architecture has some support spinning up another, node. It's not another container he's just deploying. You're scaling up workload for him. And then what we've done at Cisco is, and this is all configurable, we're getting 120 days to determine whether or not we're going to claw resources back. We're going to go through at least a full business process. We're going to go through at least a full quarter. We're going to baseline that and not go, we'll take and add 10% over the 85th percentile or 90th percentile of what that is, or to provide that, intelligent workload. That way you're able to reclaim resources in your environment, get more out of your hardware, get more out of your software, but you're not just wasting resources out there. And this is really important when you are in the public cloud, because then that is hard dollars you're paying to Amazon, Google, Microsoft, every single month. So one thing we've all done is no one gets to refresh all their hardware at once. You end up with, different CPU generations within the exact same cluster, right? So you'll have Broadwell, Haswell, maybe you have some Skylake processors in the same cluster. It'll turn on EBC mode in VMware, so it's aware of how to handle that from a feature set perspective against those individual chipsets. But a Haswell processor and a Skylake processor are going to perform very differently. CWAM, we're able to pull in these benchmark results that Cisco's created. A lot of the vendors are starting to consume this as well. We're able to pull this in so CWAM understands the difference between those generations and the architectures. So it knows, okay, I have a VM running on a Skylake 6114, and this is the performance of that processor. I have another node in my cluster, because it's still good, it's not that old. Maybe it's running a Broadwell, and it's running a 2960 or 2698 V4. There's performance characteristics difference between those two. If I vMotion that workload over, right, to free up the host itself, but this is a high-performance CPU, CPU-intensive application, now it's not going to run as well. Now I'm going to expect that spike up. So CWAM understands those updates, so it can make intelligent decisions about where it moves things in your environment to get you better placement and not have that degradation by trying to balance out and then cause an issue. Right, so the road to hell is paved with good intentions. This application is trying to take more data into account so that it's not going, hey, this host is busy, let's move this workload off. Oops, that system's much slower in general. Now I have a real noticeable performance impact in my environment. As you go through the cloud journey, right, and this is public cloud, private cloud, right, everything is about this constant cycle that you kind of you go over again, right? You're going to assess the environment, do I need to, am I going to move this application to the cloud? Am I going to move this application to my private cloud? Am I going to treat this differently? Right? You have to build a plan for you to migrate, and then you have to optimize. And this is going to happen over and over, because if you start using cloud-native tools, you might migrate this over to AWS because they have the coolest EKS environment out there. Someone else comes along that has a different offering, you're going to go through and reassess and migrate all the time. So, this is just kind of that kind of higher level. How do you go through the process of migrating and optimizing, right? What we're trying to really solve here is the optimize piece, right? If you're continually optimizing your environment, it's going to make this assessment and migration a lot easier. Right? If I know I'm constantly optimizing the resources the system needs, when I go and move that from Azure to AWS or back on premise, because I'm constantly optimizing, I don't have to worry about, okay, Amazon's running this hardware on the back end or gets these benchmark results. I hope I get the same on premises, right? You're able to understand that and let the system resize it as that happens. So this is just a little bit more in depth about CWAM and titration, right? So, yeah, perfect. 3 more slides, I think. So, with the, as Kenny mentioned, spine leaf architecture, everything's moving into the data center. And the reason why is 86% of data center traffic will be east-west by 2020. Hyperconverged infrastructure from anyone was a huge amount of east-west traffic on your network because your hyperconverged nodes are sitting on that network, and now all of your stored backend traffic that was contained within an array is now spread across your network itself. So between apps talking to other apps, right, taking telemetry data, putting it into a system, so much more is going east and west. When you have that spine leaf architecture, you're 2 hops away from everything. So when you have that, you're able to, give your network that consistent performance, that predictable performance within your environment. So when we take titration that has those sensors everywhere, we can then take that component I talked about earlier, where let's say we have these VMs that are far away from each other, right? I have a multiple leaf environment. Maybe I have one VMware Hyperflex cluster hanging off these 2 leaves, another one hanging over here, with VMs that talk to each other, and that's going up and across my network back over. Well, taking that telemetry data from titration, plugging that into CWAM, if my network exists in both places, I can just move that VM over to that other cluster. And that, so it really helps,
Too many localized VMs cause
congestion, right? So if let's say I have too many localized VMs with a ton of network I/O on a given host, I can have congestion on that host, right? So it's kind of like that hotspot I created within the environment. The picture does cover that. So the good news is it's in a really dark font, so you probably could have seen it anyway. Need to change that. So here's how we're, what CWAM's doing, right? It's kind of a pictorial example of how it sees the traffic in the environment, right? So these, again, it is very quick. I'm just going from one leaf, I'm 2 hops down. However, what if I can just move those onto the same host, and now it's not, moving across my environment. So, look here. This is kind of how it makes its decisions. Right, so a vPod, and that is your virtual pod, and then you have your data center itself, right? So it kind of goes through, making a decision matrix around how it's going to move things within the environment. Skip ahead here for time. So with Hyperflex, we can also take that telemetry data from Hyperflex, bring that into next. So let's say you purchased multiple Hyperflex clusters in your environment. Maybe this one over here is an all-flash environment. Maybe this is a M4 hybrid array, so our older generation hybrid array. And then over here, let's say you decide you just need all the performance in the world. It's all NVMe cluster. So the problem is, well, now how do I account for where things go in this environment, right? It's a manual placement by that VM administrator to know which HyperFlex cloud do I deploy to because of the storage IO performance I need. We can then take that telemetry data across and get these actions in here and understand where things need to move based upon the performance, right? CPU and memory is fine on this VM, but I'm bottlenecked on my hybrid array performance. Let's move that application over to all flash to relieve that contention, right? So it's not necessarily my problem is with my hardware isn't sized, properly for the application I'm running. By having these multiple clusters, I'm able to do that. Yet, same thing. We have those compliance rules. We can say this application, I don't care what it uses, it's a dev system. Please don't put that on my all NVMe hardware. Someone's going to order that, it's going to let you know, hey, I wanted to move this, I can't because of this compliance rule within your environment. And so this is, how do we go ahead and, further scale this environment out and have that flexibility based upon the clusters, right? I may have a handful of apps that need all flash, a lot that work great on hybrid, right? Too many times in a buying center, we have to buy for the least common denominator, right? We have to go, well, this app needs all flash. I'm just sort of going to have, one big all flash cluster, and we're spending extra money we don't need to, right? As your environment grows, you can then start to see the performance of the environment. If you have different clusters, and as that application performance changes over time, C1 is going to go ahead and move that dynamically for you between the environments. And it can be put in a recommendation mode, right? Like, obviously, the Nirvana is when the system manages itself, right? Like anything, we crawl, walk, run in IT. You probably don't turn this all on, all automated day one in the system, and then go, well, I just hope this works. Right? There's a level of trust you need to get from any system, right? So you put it in, you let it learn, and then you can go into that mode of let it automate. Right? So if you let it learn, and we give data in as few as an hour, let's say I only let it run for 4 hours, and I say, okay, go ahead and make all your decisions, but all my processes happen at night. Well, now it may have moved things that I, as an admin, knew, oh, I placed them here because of X. It went and moved without me, so we always recommend giving it that little bit of time before you go through. So, last year. So it does have the option as well, I mentioned, it has what-if scenarios, right? So as you grow the environment, what if I move this over here? What would happen? Right? What performance am I going to see within the environment? What is the resource load going to look like on that host if I was to move this within my environment itself? And I am out of time. So my
Thank you.
two guests.
I do have a question on the WAM though. What is the actual product called?
So it's Cisco Workload Optimization Manager, and it's based on Turbonomics.
Okay. So is it customized Turbonomics, or is it
It is. So we OEM Turbonomics and then customize it. So okay, and a lot of that customization is to do all those integration works into the other products.
Gotcha.
And
then as far as extensibility, I mean, do you guys have plans to do like a Blue Medora type extension for Turbonomics so you can get into other areas, or are you relying on VMware to kind of do VROPs as well?
Yeah, we're not really relying on, right, these could complement each other between VROPs and having CWAM. And then, I have always seen VROPs as that more reactive mode, where CWAM is really built on the idea of being predictive. Right, there's value of having both in your environment. Okay. I think as time goes on, maybe there isn't the value down the road of having the after-the-fact notification if my system's managing it predictively for me. I think that, I don't know on the current integration side, but, hopefully there is ability to take the ability from VROPs into Turbonomics as just another data source, and component. I haven't seen it on the list, but I can follow.
Yeah, I'm just wondering, because I mean, you've got, like, for example, if we decided to do, that product in our environment where I'm at now, the one thing I would have a hard time selling is how do I get insights, how do I get my one management tool
kind of insights into my Hadoop cluster and my, other type of kind of spiky applications that kind of go up, but then provide that to the end user. Like I can do that all through reroutes now. I can say, yeah, I'll buy this Hadoop management pack, I'll put that in there. Now you can see VMware, you can see my storage, and I can see Hadoop. I can see my Hadoop cluster if I Hadoop.
Yeah, we'll do that. Workload optimization does.
All that.
Yeah, we're not sure on the Hadoop side.
Yeah, I'm pretty sure it works with Hadoop.
Okay.
Okay, so pretty much anything that is virtualized.
Okay, awesome. Great. Thank you guys.
Yeah,
Cool. Appreciate it.
all right.
Chris, and when we're on the call, we're just going to take a quick break here, and then we'll jump into Morpheus.
Okay, sounds good.
You're talking, you're on mute. Hey, Chris, this is Jeremy. We're ready to start back up.
All right, sounds good. Okay. Thanks for virtually having me. Chris Bungie with Morpheus, sales engineer with the slew of our sales guys here.
We can see your screen, by the way.
Yep. First and foremost, kickoff, I'm not sure how familiar everybody is with Morpheus. Morpheus is a company that's actually underneath Bertram Venture Capitalist. They're a company that they buy low-tech, no-tech companies, and they inject technology into it. And that's kind of how Morpheus came about. About 8 or 9 years ago, they had a need to start managing multiple infrastructures for all the companies that they were purchasing, and it was built internally. And then about 3 years ago, we hit the public market. Also wanted to throw out, my sales guys kindly reminded me, we did win the Gold Award at VMworld Las Vegas for Agile Operations and Automation. So making some major strides in our application.
Awesome.
So within Morpheus, we focus on the provisioning aspects of applications and containers, VMs, and physical hardware. That's our bread and butter. And then what we have around it is where we're starting to ramp up our monitoring, our logging, and some of our tasks such as guidance and VM sprawl recognition. Within Morpheus, we have two methods that we really look at for doing provisioning within any of your cloud environment. Cloud being any resource that you have connected, whether that's an on-premise cloud or if that's, once again, physical hardware, maybe under UCS or HP. Instances are as oh, did it stop for you? Oh, no, it says it works. So instances are a single-tiered app deploy. They're going to be something like for a base OS, like just maybe a Windows-based OS or Apache server, and we can deploy multiple servers in one go. Whereas we have blueprints and applications, those are going to be our multi-tiered applications. That's where our devs really start to turn up the whole environment so they can do product testing. Your middleware, your database, your web app. We have some customers that spin up everything from the ground up, brand new AD infrastructure, all via API calls back to Morpheus. So first piece here, I'll start with the instances and how we approach that. Out of the box, we have multiple options. Once again, instances can be just an OS. It can integrate directly with the cloud and just call the templates available, or we can do more and lay down some basic applications. I like to hit on our Apache here because it gives us a little bit of options to present our users, and it's a quick application. we have two fields here that come up when I first click provision, and they're groups and clouds. Clouds, since they're any endpoint, they exist in a one-to-many ratio with our groups. Groups are where we grant users access to the chunks of clouds we want to grant them. So in this case, if I was a user and I had access to the group Ansible, I only have access to these 3 clouds in our backend. Whereas if I choose demo, where our admins have access, I now have access to all 15 clouds we have integrated in our demo environment. VMware. I have a naming scheme in here. We can set policies for cost, utilization. We can set different policies such as like the naming schemes or even power cycles on when their systems can be up or down, handy for if you have specific dev environments in the public clouds where you don't want to be continuously charged when they're So I have selected VMware, and now I'm with this Apache deploy, but I'm presented a couple different layouts. This is because I've selected my technology of VMware, but I can do Docker on VMware and deploy a container. I can do a couple different flavors I have available in this instance type between like Ubuntu and CentOS. I'm going to pick my favorite choice and form adjust accordingly based on what I have selected. Now these fields are the resource pools, networks, and folders. Those are being synced with your review center every 5 minutes in a very brief sync time. Typically it's less than 30 seconds. And with these, we'll pull in any of the resource pools that you have that are within the cloud that you've presented. We'll grab all the networks and we'll grab all the folders, and then you can either set these as defaults or disable any values you don't want users to have. I can then add additional drives if I like, add additional NICs. This is right now integrated with our IP pool that we have within Morpheus. You can integrate with even info blocks or BlueCat, where you can enter static IP addresses. This is how that is. I don't know if I have access in the Jenkins folder myself, so I'll put that just as select for the root. And then we have a plans piece here. Now the plans piece, it's showing me a pricing, and this pricing for private cloud is based off of numbers internally. So this is just a demo price to be projected. However, if I want to do a cloud comparison, I can see real pricing against public cloud on what it would cost me to deploy this, and any of my other private endpoints, such as like OpenStat for Mac statements. So right now, at my sizing, it probably makes the most sense to go to Google. It's about $6.50 compared to my $13.50 on my VMware environment. If I make any changes within these, my pricing reflects that as well, and I can still make a good decision on where I want to deploy this. Additionally, we can do other items here at this point. We can join different domains. We have several in our demo environment here. I can even set environmental variables so I can be up and running in the OS and ready for the application install. On this page, we were presented with a workflow option, and this is where I can run ad hoc workflows. Instance types that you create, you can associate your own workflows that always execute. Maybe you have base applications or base configurations you need to do to every template. Those can be baked into your instance type. Here is where I'm going to run something specific to my application. Maybe in my Apache server, I have a specific chef runbook that I need to execute for my app to be up and running. Additionally, we can integrate with a slew of load balancers, F5s, NetScalers, H8 proxies, any of the public load balancing options out there. And then we can create the pools and add the members, set sticky mode, set the SSL cert, set the balancing, and really take one of the day two operations, I don't want to say out of the hands of some of your networking guys, but maybe help them out and free up some time in the deployment. Additionally, at this phase, we can set scaling thresholds, so we can auto-scale your application based on any threshold that you have created. And we can actually scale across multiple clouds in your environment. Give them a ranking on where you want to scale, and we'll deploy depending on that ranking. And another key feature that a lot of our customers ask for is lifecycle management. Really, when you want to hand off an environment to your devs, you don't want that just to sit there and never go away if it's not being used. So here, I have a policy. It's not strictly enforcing it yet, but I have a policy that says this machine is going to shut down in 1 day and expire in 2. I can also set my power scheduling here. So maybe it's only on it during the day and it turns off at night, save some additional price. Final page, I'm presented with the summary of what I'm about to deploy, my auto-generated name, how much it's going to cost. Sound good to go. And I just get a rundown of what it's doing within the environment. The ETA is based off of historical runs. So as your hardware gets better, as your processes get better, that time goes down. And we can get in further breakdown of the individual steps that are happening within the history tab. So maybe a week from now you realize, oh, you know, I should have added more memory to this, or I need to reduce cores because of licensing. When anybody does any other action against this, they'll track who did it, what they did, the time, and then if it's any sort of scripting, we'll capture the output of the script and capture the error code as well to do some failure and retry actions. One other point I'd like to hit on as well, especially with this being VMUG, the console in here is the native MKS console for VMware. It's the we have the console, SSH, and RDP. And once this finishes actually doing the clone, I would actually be presented to the console. So that in itself is the baseline, I'd say, deploys within Morpheus, and then doing some of the actions and deploying. I could, you know, restart my server. I can run additional workflows or scripts against it. I can reconfigure it and adjust the drive sizes, any of the cloud infrastructure pieces too. Maybe I need to change plan sizes. And it's important to note that we do this not only in VMware, but we do this across all clouds out there. We have a lot of users, Alibaba, IBM Software, Azure, AWS, GCP. We have a couple MSPs who are just running solely OpenStack. So we're not limited to one vendor in there. We handle them each the same. So say I bring in my environments. Oops. Oh, I can hit that one too. Say I bring in my environments, and you know, we start deploying. I want to know what I'm deploying, where are my costs at. We do a couple different tabs here. One here I like to hit on is analytics. It's going to break down our month-to-date costs by cloud. You can see we're doing a lot right now in Nutanix testing, but we have a lot as well in our VMware vCenter environment for costs. Breakdown right there. We can drill down different ways if we would like to just look at, you know, different group costs, different instance type costs, and really just see what your environment is doing. Another neat thing that we're starting to expand on is some of the breakdowns of our utilization in our environment, and this kind of bleeds into our guidance as well. So we'll look at, this is CPU utilization versus price. I can see that my lifetime run on this is $340. My utilization, my CPU is 5.5%. Maybe this is a machine I don't need anymore. Maybe this is a machine I start reducing resources or add power scheduling. I can just see I'm spending a lot for really not a whole lot of utilization on that box. Or conversely, if I go down here, I have a machine at 100% tax. I've only spent $23 on this. Maybe I need to look at either growing out this environment, see what it's doing. Maybe there's an issue in the machine itself that's causing the speed. And we do this not only for the machines you have deployed within Morpheus, but anything you have ingested as well. Those show up here as unmanaged, but we'll associate the cloud generic pricing, and we'll start capturing the different statistics on those machines as well. And then that would lead to where then we start making the guidance recommendations on those. So we'll do sizing up and down, both with your provision through Morpheus and your brownfield environments. You can see like vCenter machine we deployed, saying memory down, it'll save me about $40. I get the rundown of what it wants to do. It wants to move my RAM, or cut my RAM in half, make a conservative approach, take my utilization to about 50%. I could actually execute this from my window right here. Q1, we're bringing scheduling with this. As I heard mentioned, it's nice to not have to necessarily wake up at that 1 a.m. to do a task on the dot to hit your change control. Maybe it executes and you have some checks to make sure, automated checks to make sure it happened correctly. And then the other piece I really like to touch on is we handle groups and clouds. That's sort of kind of, let's say, internal tenancy. So in your company, if you have individual teams, different dev teams, you have your back-end resource clouds here, and then you break them down into the individual groups and grant access to the users that way. That works well when it's a single company, but when we're talking like MSPs, where you are going to have multiple tenants, we fully support a master and subtenant environment where everything can be segregated. You can do white labeling. You can change authentication into Morpheus. So we support like SAML, LDAP, Active Directory, custom API call for authentication, Okta. So we support a slew of those, and maybe not all your tenants underneath use the same method for authentication. So we can actually provide the connections there. And then if I just impersonate somebody here from the Pied Piper, I get my custom white labeling for my company. I get my specific instance type deploys that I have. So you have that segregation, pointing at the same infrastructure on the back end, but completely different triggers. I'm not sure of the room size or the background of everybody in the room. I don't know. Is there a specific look or target right now for CMP? Something that you know companies are finding they're wanting, but they're not quite finding out there?
I don't know about that necessarily, but you know, the only experience I really have is with VRA. You know, right now, I would say that I had looked at you guys in the past for you know, as an evaluation, and it wasn't just there; it wasn't quite ready yet. You know, I am kind of interested in knowing your guys'
integrations and architecture now, and seeing where you guys are kind of going with the product?
Sure. Awesome feedback. Yeah, I agree. So I was a previous customer of Morpheus. I worked at Quicken Loans. I went through the whole POC thing when I first started there, and at that point, Morpheus was just hitting the public market. We felt, you know, let's see where it's going, the vision of it, and I was comparing the big dogs at that time, and honestly, Morpheus was still kind of the leading edge of technology we were looking at, that we felt, well, let's wait. We can still do our manual processes for now, and let's look at it in 6 to 8 months. So 6 to 8 months come around, we make our requirements again. We pick our 3 we're going to go side by side, and I like to joke, but in all seriousness, I had Morpheus up so fast I was deploying my VRA POC with Morpheus. The deployment scale, the upgrade paths, in comparison with the two, I had always found a lot of my VRA deploys have had to be, you know, kill the environment with fire and restart. Several different management boxes just to do my connections. I heard someone mention Blue Medora or the plugins. So Morpheus, it can be deployed as a single client. It's a RPM update to upgrade Morpheus. It's fairly quick and painless. You can go into an HA deploy with a MySQL, a messaging, and an app tier, and even that just behind some simple load balancing. It's active deploy, and it's for updating that as well. But the nice thing is our add-ons, which unfortunately George couldn't make it here, and he would have had his little bit of slideshow there. We have over 75 native integrations within Morpheus. All of our integrations are via API calls. So like if I go to, we do some things within Morpheus. We can do some script management for you if you don't own these products on the side. So we can like do PowerShell scripting, SSH, Java, Groovy. But we also integrate then with Ansible, Chef, Puppet, Salt, Infoblox, BlueCat, ServiceNow, Sharewell. So we're looking at all these native integrations to really just be the glue for the big hitting infrastructure pieces for companies. And our vision around that is we're really fine-tuning the provisioning piece. Now we're going to starting to look at where can we integrate with or monitoring. So we brought in like we do some basic integration right now with App Dynamics, but we're looking at branching that out further. And what could we do with like integration with items like Turbonomics to do some of their guidance pieces as well.
Okay. What about, you know, your kind of bread and butter VMware folks as far as, I mean, do you have a built-in orchestrator, or, you know, are you leveraging VRO or HPO for that type of thing? Is there VROPS and log insight integration?
Yeah, so we don't utilize VRA or VRO for any of our orchestration pieces. I mean, so for the initial provisioning, we're going to do a direct call to ESX or vSphere, and then we're going to use our automation workflows to do any of the post-execution steps there. And our automation workflows function a little differently than the orchestration within VRO. We're going to look at phase deploys and or phase of the task, and then we're going to execute based on the ordering within that. And then within the tasks we're working around, we've just implemented configured on this end here. just implemented some retry logic in there. We're working at doing rollback on failure and failure alternate actions as well, which is kind of, I know the GUI-esque creation methodology and VRO with connecting your steps and doing an if-or kind of switch. But so if I create a workflow and if I have some tasks in my post provision and I have some tasks in my teardown, the teardown will only execute when I actually go to do the removal of the VM. They'll now trigger that phase and go, oh, okay, I need to remove myself out of Active Directory. I need to maybe release my IP and our own custom IPAM solution. But it's fully integrated within the single Morpheus, I call it appliance, but the application.
Gotcha. So what's the ambient visualization of this process? Is there a way to see, you know, like all the steps that's been created for a blueprint or an
Yeah, so the workflows are going to be essentially this. I mean, just a rundown of, we don't have any larger ones in our environment here, of the steps that are going to take in the phases. Now, the blueprints, if you're starting to do a multi-tiered application deploy, fortunately in a demo environment, I only really know this one and it only has 2 tiers. If you want to look at what the boot ordering is and the hierarchy, we'll present that in a preview. Now, both of these tiers actually deploy at the same time. That's why we don't really see any difference between them. But I'm working with a customer right now who has he has a 50-tier environment that he spins up. He spins up 100 VMs within it was like 15 minutes on his test hardware, VMware hardware in his environment. And his preview is immense with his boot ordering and what applications need to come up first. And then he also does a lot of it. We can build the blueprints and we can export import via YAML and JSON. So he actually takes a lot of this code himself and then just quick hacks the pieces he wants and creates new blueprints just repeatedly via the API, and never once has to touch anywhere in the GUI to create those for Zen users.
Okay. Yeah, just for me, maybe this is, you know, is to know like an end-to-end visualization. So I like how it breaks down here, like the structure, but like what are all those tasks? Like what's going on with some of that?
Sure.
Yeah, this has come a long way since I've last seen it. This is really impressive.
Yeah, we have our estimate, the 3rd of December is our last major release of the year, but our feature releases are every 6 weeks. And
okay.
I mean, we have major things added. One of our more recent feature adds added NSX support. We have ACI support, so we can create any of the new virtual switching. We're working on integration right now to bring in some of the operational tasks as well, to start being able to allow users to do tasks not just around provisioning and virtualization management or server management. So maybe, you know, configuring switches, onboarding new users and setting them up, etc. Also, if it's been a while since you had seen Morpheus, we've also added additional blueprint types. So we have integration with Terraform, ARM, and CloudFormation. And so this allows us to kind of take the top off the box. You can deploy things that aren't necessarily physical endpoints within Morpheus yet. So Amazon, you can deploy EC2, S3, RDS within Morpheus, but maybe you want to spin up some net new thing in Amazon, as long as there's Terraform scripting to it, you can bring that into Morpheus. We'll parse out the variables within it. Actually, I don't know if we have one in our demo. We'll parse out the variables and present it to a user and basically run your Terraform execution as well. I don't know if that one worked.
So a single appliance, or I mean, I'm assuming spinning up 100 VMs within 15 minutes. Is there how many nodes do you have to do that? Like, what's the scale out for it?
So that customer who's spinning up those VMs, he's on one machine. It has 20 gigs of RAM and 8 cores on it, and it's handling all of the tiers of the application. So his bottleneck really is the RabbitMQ messaging on his machine right now to do that many spin-ups. And so about 100 VMs is his threshold. So we're talking right now of breaking him out into an HA environment. It's just literally all they're going to have is 2 front ends, 2 messaging tier, and then he's going to do an active-active MySQL database.
Okay.
But a lot of our production users have just stayed on the single node because we're not data plane. They haven't seen the need to break it out into an HA setup because they haven't hit any sort of bottleneck within the single node itself. In fact, when I had deployed at Quicken with my initial POC group, we were doing, before Morpheus, it was taking about 2 months to get you your VMs that you requested. And we would get those through a slew of ways. We had 3 different ticketing systems. You get the emails, the walk-ups, etc. We had 4 chat systems. And we took that, and in our environment, we took it down to 5 minutes to get a base VM and about 10 minutes to get a SQL cluster up and running. And the word got out a little too fast before we could actually break off of our POC box and build out an HA environment. And soon we just had every user using that POC box as production. Any other questions around the Morpheus?
I see a backups tab there. I mean, is that for integration with backup vendors, or what is that?
Yeah, so we have integration with Veeam, Avamar, and Commvault, and then you can schedule the backups during your instance deploys as well. You can set the scheduling. Oh, I forgot we have service as well.
Okay. Is that on Rubrik or VC or anybody?
I'm sorry?
Any plans to add on Rubrik?
Anything on Rubrik, you said?
Yeah. To add Rubrik to the list of supported backup targets?
So that's one of the nice things working with Morpheus and with our agile release cycles. Pretty much any feature you see within Morpheus has been customer driven. I like to joke, we're on 3.5.2 right now. I like to joke and say 3.x should just be called the Chris Bungie release. So I requested the build outs for the F5 integration. I requested the Terraform integration in there. The agents, the Windows agent used to just do capturing logs and doing some of the health statistics. Because of our environment, I requested that it handle the script execution as well, so it does that. So the Avamar piece was just added in one of our last releases for a customer. So it's very much customer driven.
Gotcha. And how many customers do you guys have right now?
I do not know. I've been with the company now about 3 months, and just from what I brought on, I'm at about 10. So, and it's been public for about 3 years, and we're talking enterprise size MSPs or full corporations. As a company, I wouldn't know. I'm not that far on the sales side.
Yeah, we need George for that one. Okay. What additional, I mean, I see monitoring services, as far as like the complete vision of this, so really it does VRA, it does VRO, you know, kind of all in one. Does it also do monitoring, or is that really piece for the analytics portion?
The mic was actually making a really loud noise during most of that.
Sorry, I was just asking about, like, as far as how deep, I see the monitoring tab, so how deep does that go? Is that really just for the analytics so that you can get updates on your builds, or is that, like, true monitoring?
It's I would say in the early stages, it's more of knowing when to either they tie into our thresholds for doing some of the auto scaling, or we'll do container and VM monitoring. So if we notice it's down, we'll if you haven't muted monitoring on it, we'll restart the app. And then we'll do a couple other additional checks as well. So you can do web checks to see if your application's functioning, and then that can trigger items within Morpheus. It's not going to be the like in-depth, like what are my read-write times on a database. Like literally the SQL server check here is to make sure that a query comes back and make sure that your app is responsive.
Gotcha. Okay.
We do have users who take this a little further and they create their own API checks as well. That's, I'd say, the our advanced side of users. That's something we're actually targeting, though, hoping to have that rolled out. I don't know the timing, but in Q1, getting the operational stuff, ramping up monitoring. I touched on the pricing. We're looking to get further into the pricing integrations with the public cloud as well. Right now, we're doing a poll for the public API on the prices, and then you can add, we allow markup prices and adjustments. So if you have contractual prices to Azure, you can input that and make that change. But we're looking to get the actual subscription costs, egress traffic, et cetera. And that's a Q1 target of ours as well. That's the plan. So we have price sets, and then we'll capture the pricing.
And so you mentioned Terminomics. Is there any integration with VROPS right now?
Not right now, just because, not direct integration. Morpheus is, well, the access you have in the UI, you have the same access within the CLI and the API. So the nice thing is there are some customers who ask for an integration, maybe it's not on the roadmap yet. Because you can call Morpheus via the different applications easily, you can send the consistent payload from maybe something internally built or VRO and call Morpheus to do an action, and it'll be the consistent JSON payloads, or and you're not scripting like, oh, hey, this is this cloud, now I have to send something else. With VRO, what would you be looking to specifically integrate with? Just doing some of the operational tasks, or is there something more?
No, I was just wondering on like the costs and stuff like that, and just like contention and stuff. So. Yep.
Anybody else have any questions?
Chris, I mean, do you have anything else? If not, we really appreciate it.
No, that's all I have. I mean, if you have any questions, feel free to reach back out to me. I think I'm on the invite. I don't know if you all are, but cbungie@morpheusdata.com. You can definitely do some one-on-ones or get any trial keys in people's hands.
Yeah, definitely. I'll be reaching out for like contact info so I can send out to the group so they have it in case they want to reach out and talk to you more about it. And if George, if you can connect with George when you have a chance and just have him send me the slide deck he was going to have, that'd be great.
Sure. Yep.
All right.
Awesome. Thank you, everyone.
Thank you. Appreciate it.
Good afternoon, everyone. My name is Daniel Bayansky, SE for Rubrik out of the Pac Northwest. I'm glad to be here today. My intention is to provide a little bit of an introduction to Rubrik for you, just a few slides. So I definitely took Jeremy's guidance and have definitely want today to focus on a technical demo of Rubrik, but I think it's useful to start with a little bit of context of who we are and what we're all about. So if you really think about data management, data protection, things have remained largely unchanged for the last 20 plus years. What you're seeing here is all the typical elements that make up your traditional legacy data protection architectures. You have backup software running on backup servers, you have backup proxies to interface with VMware, and APIs to protect virtual machines. If you replicate your data, there's a catalog database that manages the information about all of your backups, all the metadata, but then you also typically have additional metadata associated with the deduplication storage that you might be using, as well as purpose-built storage mixed in with general-purpose file systems and storage devices to store all this data. People are still using tape here in 2018. And of course, you have to have some mechanism to get that copy of your data off-site to protect against site failure or disaster scenarios. In that same time, all of these new technologies around public cloud, automation, and security, both in terms of the threats and risks organizations like yours are facing, as well as the technologies designed to respond to those threats, have all kind of grown up. And the reality is that the legacy architecture used today in most organizations to protect and manage their data hasn't really evolved to align itself with these new technologies around cloud, automation, and security. So Rubrik was built from the ground up as a single software fabric to provide complete data management across both on-premise data center infrastructure and public cloud. And it was designed with the notion of being able to integrate into all of those public cloud environments, to plug into existing automation frameworks, as well as to be accessible through API-first architecture, and to help organizations develop a more comprehensive policy around both detecting and responding to particular types of threats, like ransomware. So how does Rubrik work? The first thing to keep in mind is Rubrik is designed to be simple. Our founders understood that organizations spend too much time managing their data protection infrastructure. And so we want Rubrik to be simple to set up. You can have it out of the box, in the rack, protecting your information in less than an hour. We want it to be simple to use. And we do this through intelligent policy engine that's designed to integrate with all enterprise applications and allow you to define the business SLAs around protecting and retaining that data. And then we go further by simplifying the way that you recover that data, allowing you to instantly access data types like virtual machines and actually boot them up directly off of recover them directly off of the Rubrik platform without having to go through a typical restore process first before you can start accessing those applications with that data. What's really cool is we've extended that instant recovery capability beyond just VMware and virtual machines to other application types like SQL, Oracle, databases that you can actually live mount directly off of the Rubrik platform. Rubrik was built for cloud. That means that we leverage the cloud where it makes sense from an economic perspective, for archiving your data for long-term retention. But it also means that we extend the intelligence and the capabilities of the platform around the ability to enable Google-like search and single file recovery to the cloud as well. Because what a lot of customers tell us is that up until now, products that have tried to plug in cloud as a storage target behind a traditional data protection product, oftentimes are treating that cloud storage like a file or like an object, and like a tape. And what that means is that it's very hard to rationalize the consumption of storage in the cloud, and it's also challenging to cost-effectively recover that data. When you're taking virtual machine snapshots, you have to download the entire virtual machine snapshot out of the cloud to just pluck out a single file. In Rubrik, we index all of the metadata of the virtual machines at the time that they're being backed up. Then we maintain that global metadata index for those virtual machine snapshots, both on the brick as well as with the data that's being archived in the cloud. And we know where to find any individual file and allow you to extend your search across both the on-appliance storage and the cloud storage and recover single files without paying that cloud tax or that cloud penalty to egress all of that data back on site when you need to recover something. And then finally, Rubrik was built for security. Some things like end-to-end encryption are just table stakes in 2018, and our product has end-to-end encryption for all data in flight and at rest, both on the appliance itself, as well as giving you complete control of the encryption of your data in whatever public cloud target you chose. Our architecture is designed to be immutable against ransomware, against any kind of malicious modification. And then here in 2018, Rubrik has taken this step further by introducing capabilities within our SaaS platform that we call Polaris that allow us to leverage that rich metadata that we're gathering when we back up those virtual machines, when we back up the data, and leverage that metadata to actually detect anomalies within the backup patterns that could be indicative of a ransomware event. And not only alert you to that event, but allow an administrator from a single pane of glass to mitigate and drive recovery from that event with just a few button clicks. Rubrik's designed to be run anywhere. So most of our customers start with the Rubrik appliance that we call a brick. It's a 2U appliance designed to plug into your existing environment. It's all IP-based. It is leveraging proprietary scale-up technologies, which means you'll never run out of space. You can grow your Rubrik cluster as big as you need to accommodate the amount of data that you need to protect. And then we allow you to plug into public cloud storage from all of the main vendors, like AWS, Azure, and Google Cloud. Everything can be automated with Rubrik. Our RESTful APIs aren't an afterthought. They're actually inline in the control plane of the Rubrik system. That allows customers to easily integrate Rubrik within whatever automation or orchestration frameworks you may be using today in order to automate IT service delivery. What this is really about is taking the humans out of the equation for day-to-day data protection tasks and allowing you to have everything be driven via policy and the intelligence of the systems that you deploy in order to manage your data protection infrastructure much more efficiently with much fewer man-hours. So when we look at the business benefits of Rubrik, what we see is across application availability, integration with cloud, security compliance, automation, the customers are achieving data protection as a service in 2018 using Rubrik to transform the way that they're protecting and managing data. So now what I'd like to do is switch away from the slides and actually jump into our demo environment and let you see all of this in action. So what we're looking at here is the Rubrik user interface. This user interface is an HTML5 application hosted natively on the Rubrik appliance. You just attach it with a browser like Chrome. You don't need to install anything, do a dependency on Flash or Java. All of those things are in the past, which a lot of our customers certainly appreciate. What I'd like to kind of walk you through is the protection and recovery workflow for a virtual machine, because it will really give you kind of a nice overview of all the different elements that we're talking about. So here's the kind of main dashboard view when you first log in. I can see kind of at a glance information about the protection status of my virtual machines or any other object type being protected on the system here. I have an activity log that's kind of will be dynamically updated over on the side here. I kind of see at a glance status and performance information in the middle here. And then over here I have this concept of SLA domains. SLA domains are the heart of our intelligent policy engine and a big piece of what makes Rubrik simple for our customers. Because no longer are you having to spend a lot of time to build complex policies and complex schedules and map them all together to create different jobs that run at different times, windows during the day in order to make sure everything kind of works together to get the backup done each night. Instead, with Rubrik, you define a simple set of parameters that then drive the policy engine to do all of the work. So let's say I want to take a daily snapshot, maintain that in 30 days, a monthly, for a year, and a yearly, 7 years, because of some compliance requirements. Pretty typical retention requirements that a lot of customers may be familiar with in their own environments today. You'll notice here it's reflected that local retention is set to 7 years. Now, I don't know about you, but provisioning 7 years worth of retention on my own storage inside of my data center behind my backup system would be a concern. That would require quite a large amount of storage. So what we allow you to do within the same SLA policy is bring in the archival piece with the click of a button. So here I turn on the archival component of this SLA policy. And then I have the ability to select from any of the archival locations that have been configured on this cluster. Here we see buckets have been configured on AWS, Azure, GCP. We also support on-premise NFS and object storage. That can be stuff that you own today or something that a third-party hosts. So your provider has provision for you, but if it supports NFS or S3 compliant object store APIs, we can also configure those as archival locations. So once you've chosen an archival location, in this case, I'll pick this S3 location. The slider bar allows me to control the archiving threshold in terms of what's kept on the brick and what is archived to the cloud. So here you see, maybe I only want those first 30 days on the brick, and everything else from day 31 on, I want that to be archived to this location. If I want to create an archive copy that starts right after the backup, I just click this instant archive button, and now this is just controlling, again, on-brick retention. If I go back to that first tab, what I see is that the local retention now reflects where I set that slider bar. So I didn't have to change anything about the overall retention in the policy. All I did was set the archiving threshold in order to control how much of the data will be kept and stored on the brick and how much is kept in the archival target. Once you've created a policy, it's really easy to map that SLA domain to one or more objects in your environment in order to enable protection. So we're focusing again on vSphere VMs. Essentially what we do is we integrate via your vCenter service. So you essentially, through a configuration menu up here, provide the information about the vCenter servers that you want to protect. And once you're connected to that vCenter server, we will auto-discover all of the virtual machines on that system. Now, I certainly have the option to just kind of one at a time select and enable protection by mapping a particular SLA domain to an individual VM or set of VMs, but that would be tedious for me as an admin, particularly if I'm dealing with hundreds or even thousands of virtual machines. So instead, most customers like to take advantage of our auto protection capabilities, and so they'll actually map the SLA domain, not to individual VMs, but to folders or hosts and clusters within their overall VMware infrastructure. So for instance, here I can go to the shared VMs, I can see, this lab folder, and I can see that an SLA domain has been applied to this level here. And if I actually drill in further, what I'll see is that all of the VMs inside of that have that SLA domain applied automatically, having been derived from the parent folder that they're in. So what this means is that virtual machines in this folder will inherit this protection, and new virtual machines moved into or instantiated into this folder will also automatically inherit this protection. So no longer do you have to worry about virtual machines, once these policies have been mapped to the right containers, not being protected. They can just be instantiated through your normal provisioning workflows. You can be confident that they're going to actually be protected based on the business requirements.
Can you also do that via tags or like host names? Like say you want to use production in the host name.
Yeah. So for instance, we can map these SLA domains to different, like to particular hosts. And what's really cool is that if you do like a host assignment here, and then you also do a folder assignment, the folder assignment overrides the host assignment. So what we see customers sometimes doing is like an intelligent kind of policy mapping where they apply a catch-all policy to the host, so that any VM that ends up instantiating on the host, regardless of where the VM admin puts it within the folder structure, wherever they don't file it array correctly, it's still going to get some sort of basic protection. Maybe you've assigned a 7-day policy with no archiving, just as kind of cover all your bases. And then when that VM gets properly moved into the right organizational folder within the vCenter folder hierarchy, it'll inherit the correct policy based on the assignment. All of these assignments, in fact, it's worth noting, every click in this user interface is an API call. We expose that API through our Swagger UI and through a full set of documentation on the cluster itself. It's all natively exposed. And so things like SLA assignments can actually be driven through external orchestration or automation workflows. So for instance, if you have a provisioning workflow in say the site of vRealize, you can have that workflow include the steps to assign whatever SLA domains to those virtual machines before they even instantiate and show up on the environment. So you can essentially just make that part of the provisioning workflow programmatically, kind of really driving data protection as a service again. Make sense? Mm-hmm. Now up at the top here, you see we have this search bar. What's really cool is that this is kind of for searching objects on the system. This is kind of like the administrative search bar. So I have the ability to just, for instance, type a few characters here from, a virtual machine that I know that I'm looking for. And then what it's going to do is find matching objects. And notice I didn't have to start from the beginning of the name. I was able to just kind of start internal to that string and have it, find quickly what I'm looking for. So this is a virtual machine that we're going to kind of use and focus on for the rest of this demo a little bit. So here I have the ability to kind of get an overview about the virtual machine. I see how it's being protected. On the right side, I see a calendar view that shows me all of the available recovery points, all of the available snapshots. And then down below, we see essentially a activity log for this virtual machine that lets us kind of see what's going on. So for instance, here I can see, backup was completed at 1:58 p.m. and then it was replicated. And we can kind of see some other people are using this in their demos, and we're going to kind of go through this ourselves as well. So there's a couple of things that I want to highlight when we talk about recovery. So, I have this calendar view. I can go back and pick a particular date, say pick the 25th. Here I see a list of all the available snapshots. Notice there's one happening every 4 hours as per the policy that's assigned, the 4-hour policy. You also see that it's being replicated because replication is enabled on this policy here. And we also see this little cloud icon that's indicating that there's an archived copy in the cloud as well. So what we can do is, click on this list here, we'll see all these different recovery options. Now, one option is a traditional recovery file. So you have the ability to, search for something. So I currently have for those files a good one. Here I see I can quickly find, like my host file. What's really cool about this interface is that it lets me select multiple things and build this shopping cart to drive recovery of multiple items across the file system with a single click. So that's pretty cool. Some other capabilities we have is I can actually search for the file that I'm looking for a single file and I don't know which snapshot it's in. I can actually search up at the top here and it will look across all the available versions. So here I can find the particular file I'm looking for. At the top here, and I'll see all of the available versions, and I can pick whichever one I want to recover. So that's pretty cool. So now, if I take a look here at this view of it again, I can see some other options. These are the most recent snapshots. I have the ability to export the virtual machine, which just pushes the DMDK files back. These first two options here, mount and instant recover. These actually instantiate an instance of the virtual machine within VMware. So I pick a target host. And this is, the instant recovery or live mount capabilities that have kind of been in the market for a number of years. But with Rubrik, because of our particular architecture and the way that we leverage a significant amount of the actual compute resources of the independent nodes in each brick in order to enable you to do dozens of these live mount operations simultaneously on a single 2D brick. So the ability to do live mount and instant recovery at scale is a big part of what we enable customers to do. And that means you can instantiate entire application sets or even entire data centers within a very short time window, and then do storage in motion in the background to recover that once the applications are up and running.
So can you explain your architectures a little bit for everyone? So how is it set up? Is it 4 nodes per brick, and then does it scale out, like every brick does so many backups?
Yeah, so our architecture, as I mentioned before, is a scalar architecture that's designed to take you out of the work of having to administer all those independent components. So within a single 2U brick are 4 independent nodes. Each node has a certain amount of CPU and memory and storage associated with it. And then they're all clustered together with our proprietary scale-out cluster technologies that include a distributed metadata layer and a distributed task framework. So what that means is that the data can be ingested on any node, a backup job can run on any node, you can do a live mount of any particular virtual machine on any node. The system will just automatically allocate and balance the use of resources across the entire cluster, whether that's made up of a single brick with 3 or 4 nodes, or whether that's 100 nodes spread across many bricks. So the idea is that you don't have to make decisions to make that happen. The intelligence of the underlying policy engine and the task framework and the metadata layer do all of that work to balance the workload across the availability of all the resources on every node in the system. Does that answer your question?
Yep. Thank you.
Awesome. Let me go back to that virtual machine, because the thing that I want to kind of show as the final recovery piece is capability. So you've seen how we can leverage cloud to archive this data for long-term retention, and the economics of AWS S3 storage, of Azure blob storage, particularly the Cool Blob, the Google Cloud Nearline storage. These are very inexpensive object stores in these public cloud providers, and they make for a great location for the longer-term retention of your backup data, especially when you compare the costs to doing that on premise, and you take into account the appropriate architecture, in this case, Rubrik's approach to creating that metadata index of the objects being protected when the backup happens, and then enabling that single file search and recovery out of the cloud repository so you don't get hit with egress charges unnecessarily. The other way that we leverage the cloud and that we have customers kind of really pushing the capability is through the ability to launch on cloud. And so there's a couple things I'll point. So first of all, we have this option here called cloud conversion. This is turned on from this VM, and that kind of that's what we'll use for the demonstration. When you turn on cloud conversion, it'll take the most recent snapshot that's been archived into the cloud location and convert it into a native AMI in the case of AWS or a native PHP format in the case of Azure, and then allow you to instantiate and launch instances on demand from that converted snapshot. So you have a couple options here. This is basically the programmatic conversion that would help you do things like TR in the cloud by essentially taking the most recent snapshot every time it's archived and doing this conversion process.
What about if I had a mass migration to the cloud? Do you guys have somebody that would take like 1,000 VMs and try to do this conversion process with or anything?
Yeah, so we have customers that are essentially, because all of this is accessible programmatically, via even these operations to do stuff in the cloud, we have customers who are doing exactly that, where they're essentially archiving their large numbers of virtual machines are being archived on an ongoing basis, right, for long-term retention, and then essentially with a few clicks of the button, they can instantiate these entire application or data center environments in those cloud target environments in a very quick period of time.
Have you had anybody use this for, let's say, vSphere 5.5 migrations that they're trying to get off of to go to like vSphere 6.0 or?
Well, certainly as a platform, right? Backup software and backup platforms have been used to kind of enable migrations for some time. We certainly, because of how easy we make this now, we integrate natively with the VMware capabilities. We see customers using us all the time to kind of help provide a pivot for supporting those kinds of migrations. So what I'm actually going to do here is launch, kind of go through this process of launching instances on the cloud. So I'm going to select the cloud target. You'll notice here it recommends an instance type based on the source VM. But I have the ability, if I wanted to choose a different one. So for instance, if I wanted to instantiate a medium instance with more RAM, I can do that. I then need to pick an appropriate network, appropriate security group, and then I can click submit. And if we scroll down to the activity list down here, so you'll see right here that it's started launching a snapshot. Now, the thing is that because I chose this latest backup and because I have cloud conversion, I'm not having to go through the additional step of having it convert the snapshot I chose. I chose a snapshot intentionally that was already converted. But I can do this on demand, launch on cloud on any snapshot. It would just go through the required conversion of that particular snapshot's data in order to bring it into the state where it can instantiate in the target cloud environment. So what I'm going to do now is I'm going to scooch over here. Down here, the cloud mounts. There we go. actually looks like there was some data that still needed to be migrated, so we're technically having to wait for it to do this one. So let me just do something right here, which is back to here. And let's go ahead and launch one of these other instances. It's already been converted. There it is right here. So we see this is the one that shows that T2 small instance for. It's currently initiating that instance within my target EC2 environment, in this case US West 2. And once that's booted, I can do a yard test against it, I can validate that my application's running, whatever I need to do.
Are you able to see a log on the Rubrik side of what's going on during this process, or is?
Absolutely. So the entire process is being logged on the Rubrik side. So here we see the instance ID matching the one that we were just looking at here. This is the one that was just launched. If I go back, I have a couple of places that I can look, so I can see kind of global activity log within the system. I have the ability to drill in to particular details on anything within the system from that perspective. I also have the ability, if and this is going to be reflective of all the activity going on in the system, but I also have the ability on a particular object, if I go back to the VM that we were looking at before, I have the ability to come down and actually see on a per object basis its own activity log at the bottom of the screen here. So you'll see that I have this. So here we see this successful instantiation. I can click on that. This one is a fairly straightforward activity detail. There's just one task. But I can also download the detailed server logs directly from this. Very cool. So it can allow you to both provide auditing, it can allow you to do any kind of data mining that you want from that information. Support syslogging. Actually have an integration that's kind of already been pre-built for integration with Splunk and with customers and other types of tools like that to mine that information.
Do you use the login site as well? You said that?
I'm sure, pretty much if it's being used within an enterprise, someone's integrated with our API.
Okay.
That's really all I wanted to kind of go through today, is really just kind of give you an overview of what Rubrik is and kind of show you the different protection and recovery capabilities with a focus on VMware. Now, it's probably worth noting that while I focus on VMware, we do fully support other virtualization platforms, including Hyper-V and Acropolis, so you're running Nutanix in your environment as well. We also have support integration with the cloud directors, so you can actually set up and apply policies, the SLA domains, to VAPs and protect them as holistic sets of virtual machines. And then we have the ability to support other enterprise workloads, including physical Windows and Linux hosts, NAS shares using XMPP and NFS, SQL Server databases, Oracle databases. We're just introducing support for SAP HANA. There's really, a lot of really cool capabilities that go beyond just our ability to protect VMware virtual machines. But given that today is VMUG, so I want to kind of provide that focus.
How are you guys handling SQL on their Oracle physical machines and whatnot?
Yeah, so you notice we have Windows hosts, Linux hosts. When you want to protect all of those environments, we have what we call a Rubrik backup service, which is a lightweight agent, if you will, that's supported for both Windows, Linux, and now we've recently introduced support for some Linux environments, including AIX, Solaris, and MHFunks coming in the near future. And essentially, that Rubrik backup service is set up and designed to integrate, so you can say down right off the cluster. It's designed to integrate directly with those platforms, leveraging our native and proprietary VSS provider during the Windows in order to try to provide application consistency for platforms like SQL, SharePoint, and Exchange.
Awesome. Thank you. Appreciate it.
It's our pleasure. We certainly look forward to the opportunity to follow up with any of you in the near future. If you have any questions about anything that you've seen today, I've been working in the data protection space for a long time, and I'm very confident in our ability to really help you address the data protection challenges, data management challenges you have in your organization. So, look forward to that.